cloud is great. It solves a lot of real-world problems, but it's not just one cloud anymore. Public clouds, private clouds, edge clouds. The average business uses 5 different cloud providers. It's become chaotic and complex. With unpredictable costs, inconsistent security, multiple management tools, and different formats for workloads that span cloud platforms and providers. But it doesn't have to be that way. The Dell Technologies Cloud, powered by VMware, can be the one constant across your clouds. It brings consistent infrastructure and operations to your multi-cloud environment, so you can choose the right cloud for each application. A public cloud that lets you easily tap into services. A private cloud that's fully under your control. Or the edge with cloud as a service. With a true hybrid cloud experience, your business becomes more agile with simple workload migration and easy onboarding for new assets. Your teams get to market faster with simplified operations and automated processes. You reduce risk and strengthen your security profile. And with Dell Technologies Cloud, you have flexible consumption options, reducing your total cost of ownership. Like it or not, the business world often requires many clouds. Now, that's easier than ever, with consistent infrastructure, operations, and services across all your clouds. You get the cloud without the chaos. The Dell Technologies Cloud.
We are getting ready to start. It looks like we have Ashutosh, Balaji, Frank, Vivek, Vijay, and RA, and Sanya. So we're still waiting for quite a few more people. I suppose that they will be starting soon, or they'll be joining soon. I did send out, did everyone get the reminder email I just sent? Anyone not get it? Okay. Well, I'm going to go ahead and share my screen. Oh, by the way, how many people made it to the blockchain and fintech track today besides Whitney, who was there? Anyone here have the opportunity?
Yep, I did, and it was a great session.
Okay, marvelous.
Yeah.
Thank you for the feedback.
I also attended. Yeah, it was good.
Yeah, it was really interesting. Love to see the use cases. I'm from Dubai, so though Dubai has been good in adoption, it hasn't had such great social impact. So for me, this was a great one. Thank you so much.
Sure. Well, thank you for the wonderful feedback. We had, this is a record TiEcon this year. We had over 7,300 people that attended, not signed up, but attended today. Most we've ever had previously was 5,000, and we had 7,300. In the blockchain track, we had over 1,800 that attended. We've never had more than like 500 in prior years, so we almost quadrupled our previous best attendance. So really, this virtual medium is great from an attendance standpoint. I think it's easier for people to just log into their computer. Okay, so Balaji was at the security track. I heard the security track was really good too. Yeah, India was definitely in full attendance. We had many, many people. So thank you all for being part of the morning program. I'm going to share my screen. I don't know where the other people are, but that's fine. They'll probably join later. So let me go ahead and share the screen. So we have a lot of great sponsors. Like, you know, Zoom, we're on, and Zoom CEO Eric Yuan is a keynote speaker tomorrow. Facebook has a closing keynote tomorrow. We had the Stellar Development Foundation from the blockchain track. We have ServiceNow and Draper, Genentech, and many great groups. Dell gave us a very generous sponsorship, so we were able to provide discounts and also some complimentary passes. We have great marketing partners, so they've been very helpful. On the track today for the Blockchain Bootcamp, there's me, Jordan Woods. I'm the founding partner at StartChain Ventures, with my co-founder, Radhika Iyengar, who's also has written a book with me. I guess you can't see the book, but let's see if I can get it. No, I can't. Well, it's called Enterprise Blockchain Has Arrived. That's the book, and I'll tell you more about it. And so Radhika Iyengar is a co-convener and a board member here at Silicon Valley and TiEcon. So Whitney was on a panel this morning. Whitney, would you like to say a few words about yourself and your work at Microsoft and other places?
Yes, definitely. Hi, everyone. My name is Whitney Griffith. I'm based in California, Oakland to be specific. And I'm a full stack software engineer at Microsoft, and I work on a team called Commercial Software Engineering, which pretty much means that I work alongside our top 500 customers to architect and implement production-ready solutions across enterprise blockchain, big data, anything in the cloud, and I'm aligned to the healthcare industry as of most recent. Look forward to showing you a couple of my use cases, real-life examples of enterprise consortium that we created alongside some of our top customers.
Wonderful. Thanks, Whitney. Sweta.
Hi, so I'm Swetha. I work currently at Google. I work on the GKE networking team, and GKE, for people who aren't familiar, is our Google Kubernetes engine. So it's our kind of managed Kubernetes platform, but that's actually been a fairly recent change. I used to work at IBM, and there I worked in the open technologies team and focused on different open source projects. So the most recent, or the last one I worked on while I was there, was Hyperledger Fabric, which is kind of why I'm here and how I'm involved with Hyperledger. I've worked on Fabric in various kind of aspects. One is bringing in EVM support into Fabric. I've also worked on the private chain code. So if anybody is familiar with any of those things, they're very interesting extensions to the Fabric platform. I'm also currently a member of the technical steering committee at Hyperledger. And today I'm going to be talking to you guys about Fabric and kind of getting into the technical details of that.
Thanks, Sweta. Definitely looking forward to that. Morgan?
Hi, I'm Morgan. I worked at IBM. I work at IBM still. I worked with Swetha a lot on the Hyperledger Fabric stuff and the EVM chain code, and a little bit on the Fabric private chain code. And my history is mainly containery type stuff. So worked on open source for IBM on Docker and Kubernetes as well. And that is where I come from. Thank you.
Great. Looking forward to it, Morgan. And then we have two people from TiEcon. We've got Riley and Tomislav, the CEO and the CTO. So guys, give us your intros. Looking forward to all the work you're doing with identity. Sure.
Yeah. So I'm Riley. I kind of got my start in decentralized identity from a background in impact investing and trying to measure impact in parts of the world where identity is difficult, and it's difficult to really measure, how much of the impact makes it to the, to the people that you want to be impacting. And so that led me to research decentralized identity, and I ended up through that process getting hired at the Sovereign Foundation as the first employee. And so I was at the Sovereign Foundation for a couple of years. and then reached out to Tomislav, and we ended up starting Trinsic. So I guess I can pass it over to Tomislav, and you can say a couple words about what we do at Trinsic.
Hi everyone, I'm Tomislav. I'm the CTO of Trinsic. My background is in application development and cloud development, and recently blockchain as well. I got into the identity community a few years ago. I've been very active in making contributions to a lot of open source projects, one of which turned out to be the basis for starting this startup. I'm looking forward to present what we have.
Great, thanks guys. So that's a bit about our speakers. I'm going to get us kicked off with an overview of enterprise blockchain. A lot of the content is coming from my book, Enterprise Blockchain Has Arrived. Then I will share the stage with Whitney, and we'll talk about common use cases and real world examples, with me talking more about the use cases, and Whitney, like she mentioned, speaking about the real world examples. And then Shweta and Morgan will give us an overview and demo of Hyperledger Fabric. And then Riley and Tomislav will talk about their work with Hyperledger Indy, Aries, and Ursa, and the world of identity, decentralized ID, and SSI, so self-sovereign identity. So great program for you all today. You know, if you do have questions, feel free to, just maybe send us a chat message, and then we'll, maybe after we get a few chat messages, then we can ask a few questions in a row. I don't want to really interrupt the flow too much, but if we can maybe take questions every 15 minutes or so. So with that, I'm going to stop sharing this presentation.
I've always chosen to surround myself by great people who are very forward-thinking when it comes to gender issues and diversity. I think diversity is a key and central element of any environment, and I've never been in an environment where diversity doesn't lead to a better place. From a science perspective, we know that if you have greater diversity of microbes, for example, in your gut, that you're more likely to be healthy. And that's finding of diversity of microbes in your gut. If you think about the diversity of people in a working environment, it leads to a healthier environment and more innovation.
And it looks like maybe most people know all about blockchain and they're just going to come in later. And they want to see Fabric and a lot of the work that that you guys are doing. Let me just take a look at the, okay, so we don't have any other chat messages at the current time. So let me go ahead and share the screen for my presentation, and I'll get us kicked off. So like I mentioned, so I've been a technologist for many years. My background is actually, I was trained as an astrophysicist at Caltech, and I'm a 3-time Silicon Valley serial entrepreneur. I consider myself to be a blockchain technology expert, and we're going to talk about that a bit more at the high level, not necessarily at the coding level, though I did do quite a lot of coding early in my career, and built software for my first companies. Been an invited speaker at Google and Stanford and major conferences, and advisor to governments and accelerators in everything from digital health, AI, big data, predictive analytics, and most recently blockchain. And I've done a lot of fundraising for my companies and others as well, and managed global operations, generating millions in revenue. The book that I mentioned, Enterprise Blockchain Has Arrived, was published late last year. It does have an intro by W. Scott Stornetta, who's the father of blockchain. He was a physicist as well. We go into a lot of detail into not just foundations of blockchain, but also use cases. And those are the things that I'm going to be talking about during this presentation. So, you know, you may be familiar with blockchain and that it's actually a distributed ledger technology. So DLT and blockchain people kind of use interchangeably if they know the different terms. And if you're in the permission space, a lot of people speak about the platforms like Fabric or Corda, even Ripple as DLTs, so distributed ledger technologies. So they are very similar, both blockchain and DLT, in that, you know, they are really at the foundation a peer-to-peer network of nodes. And each node has a synchronized ledger, which makes it a distributed ledger. And the data inside the ledger is timestamped and digitally signed, and updates are made by consensus. The thing with distributed ledger tech, it does not require a central authority, but you can actually configure DLTs so that they are pretty centralized, right? It could just be a distributed ledger inside. It doesn't necessarily need to be decentralized. In many cases where, you know, companies are talking about the platform as a blockchain, then, you know, it can be more decentralized, but it isn't really a requirement for DLT. It just, you know, doesn't necessarily require a central authority, but it can have one. Now, blockchain, on the other hand, is a special case in that the data is stored within blocks. A lot of DLTs, they don't use blocks. They don't have to because they're not blockchains. And the reason that, you know, blockchains are called blockchains is that these blocks usually contain a hash of the prior block. And that could be the header of the prior block, or it could be all the data in the block, depends on which platform. But, you know, that hash basically chains the blocks together. And so that's what creates the actual blockchain. The nodes are decentralized, meaning that they're owned by different players. They're not, you know, the same player with just a distributed network. And the data is typically immutable, meaning that it is write-only, read-only, read-only, and, you know, you write and then you cannot change. Obviously, in many of these systems, they do have governance models so that you can make changes. Even in the permissionless chains, you know, there's talk about pruning chains and about rolling back blockchains and doing things like that. That comes into the governance model, but the foundation is that the data is immutable. I think that's pretty basic, and most people probably are familiar with that. One thing that I want to get into, and we actually talked about this ethos a lot when we were on this morning's sessions, is that, you know, blockchain is as much a philosophy and a state of mind as it is a technology. So a lot of the tracks, the people that, you know, we had present and the types of projects and use cases that they're working on, the ethos isn't one of a single company doing something, which is often what you find in Web 1 or Web 2. If you move into Web 3 or into the blockchain world, you really have something that's much more. It's about a shared experience. It's about peer-to-peer, often leading to democratization of services. It's decentralized, it's community-driven, and there's power symmetry, which means that everybody that is part of the community, everybody that's part of the effort is pretty much at peer level. And so that's why you call them peers. Nodes are often called peers in permission chains. And so this, as you might look at it, is very similar to open source, you know, community. And I actually came out of the science open source community, and a lot of the well, the science community for software spawned a lot of the open source concepts. And so that's kind of where I came from. And so it's very natural to think this way, because the scientific community operates, you know, kind of in a similar fashion. So the so that's something very important, because the kind of zero-sum game, winner takes all mentality that you have in the Web 2 and Web 1 type of environment is kind of a polar opposite. And there's this natural tension between centralized systems and decentralized systems. And we talked a bit about that earlier today. So this gets into why we have consortia and also the structure of communities. So it's important to understand this. Also, you know, the open source community operates this way. Okay, so let's take a look at, you know, what are the key drivers of transformation, you know, with the tech, because, you know, the philosophy actually has to have tech behind it in order to be realized. If you have a good idea, but you can't realize it with the tech, it's nothing more than an idea. So, you know, the fundamental concept that you often hear about with blockchain is that it creates a trust layer. And for online, that's fundamentally very important because it's really hard to trust things online, right? You know, it's easy to spoof, it's easy to hack. The dark web is actually getting to be as large as the web itself in terms of commerce. So having a secure source of truth that everyone can agree on in terms of data and transactions is really critical. And that's really a foundation. And that's something that doesn't really exist. The internet, you know, the TCP/IP infrastructure allows you to send messages, but it doesn't provide any way to test or know if those messages are truthful or accurate. And so you can see that this online world that we live in today, very different than the one 20 years ago or 30 years ago or 40 years ago in the early days of the internet and the web, where, you know, it was more decentralized and much more about truth and trust and information sharing. That's changed dramatically because people are motivated by gain, and it's been very lucrative. But blockchain is kind of busts that capability by actually creating a secure source of truth if it's done properly. It doesn't, just because you have a blockchain doesn't mean that it is going to be a truthful foundation. You have to actually execute it in the right way, and we'll talk about that more. But there's also a shared ledger across untrusting parties, and this concept of trustless or lack of trust is actually something very important, because, you know, being able to carry out commerce with in an online world where you don't know the other parties is becoming very commonplace in the world of, you know, post-COVID or COVID. It's not post anything yet, but in the COVID world, this is becoming something that's very real for more and more of the world. Automation of decentralized transactions, we're going to talk about smart contracts. But if you're going to have all these transactions, if they're all mediated by people, you run into two problems. One, people are not very trustworthy and easily corrupted. Second, it's going to be very slow and cumbersome, and it's not going to work very well. So you have to be able to automate that infrastructure. Tokenization of everything, I'm not just talking about coins, I'm talking about digital assets. So anything, contracts, you know, cars, products, people, everything can get tokenized. You can create digital twins, etc. So this capability, when you combine it with blockchain, is very powerful. We've seen just a little hint of it. It's not used that much yet in permissioned chains, but it's coming, and we talked about that a bit this morning. And then open source software. So, you know, making this a foundation for the entire space, because again, the ethos with the open source community is so integrated, is something that brings kind of I think, a breath of fresh air to the whole software development community. So, okay, so the value proposition, the Web 2.0 cloud, you know, we're very familiar with all the major tech players, one owner of the system, only one central copy of data, weak security and privacy, not easily auditable, all data is mutable, reconciliation is required when you're working between players because no one trusts the other person's ledger. You don't have, you know, dual ledgers so that everybody can see what's actually going on. So this is the world that we live in, and there's, you know, obviously a lot of problems. if we look to the blockchain world, you have joint ownership of the system. Each member has a copy of the data, which increases transparency. We're going to talk about the differences between permissioned and permissionless. Can be ultra secure and private. Again, it comes down to the technology behind it. Full audit trail by definition, because it's immutable and you have all the transactions are available and they have a consensus layer that eliminates the need for reconciliation because everyone already agrees to what has happened. So very, very different world, the ability to be a lot faster, a lot cheaper, a lot more efficient, and a lot fairer than the world that we have today. Whether or not it's going to play out exactly as we would want it is probably not going to turn out to be fully decentralized. It's going to be, as often happens like with the web, it's going to have some hybridization of centralization and decentralization. But the idea is move the online experience into something better than what we have today. So types of blockchains, familiar with permissionless, Bitcoin, Ether, a lot of the coin-based or token-based chains, the permission systems. You're going to hear a lot about the Hyperledger family. But Ethereum has permission chains as well. EOS has permission chains. There has the ability to create a permissioned version, or there are permissioned versions out there. Corda are from R3, obviously another one. So there's a lot of permissioned types of systems. If you look at permissionless, anyone can join the network, which is why it's permissionless. Nodes are pseudonymous. They're not anonymous because they actually do have a known value. There's a known address that's affiliated with that, and when it carries out transactions, you know that particular node did something. You may not know who that node is, but you know that it did something. So there is the ability to track it. That makes it pseudonymous and not anonymous. There's high transparency because you have block explorers and you can actually track and carry out forensic analysis to understand what is going on in the system. And that's actually by design, right? You really want to know what the transactions are. Everybody should be able to check what has happened. And then there is a lottery-based consensus method. The lottery-based consensus method that we know as proof of work or proof of stake are pretty well known to most people. It's a very different consensus method than what you have in the permission systems, which don't have rewards, token rewards. And often these token rewards that you have in the permissionless systems, they're the ones that create more currency or more tokens for the system. So you have miners or minters or whatever, type of system you have, they are going to be creating new currency or new tokens by this consensus process. And it's a way of paying for this. Because it's paid, it creates a certain amount of honesty around this process. It's focused mostly on B2C and C2C. And one of the main things that you often hear about is it's very low throughput. Now, because of the low throughput of these systems, the business community, starting in 2015, really looked and said, okay, what can we do to take the underlying foundation of what we've got there and make it more friendly for business? And so in business, it's different. You actually want to know the entities that you're interacting with. And so in a permissioned infrastructure, only known entities can join, right? So your node must provide KYC, AML information in order to become part of the network. You're going to get vetted. Your specific node may not be known, but all the nodes in the system and who are the different players can only belong to a particular set of companies or entities. Privacy and confidentiality are key. So a lot of the transactions are going to be carried out so that you can actually obfuscate information And businesses like to know who they're trading with, but they don't want to tell the other parties everything about how their business operates, because if they did that, they would lose competitive advantage. You have to work with competitors, you have to work with others. This actually is an ecosystem spanning technology. So it allows for doing that actually at scale much more efficiently. But, you know, there are privacy and confidentiality concerns that have to be in place. Otherwise, no one would join these networks. No one's going to carry out business. So a lot of people in the permissionless community say, oh, this makes these not a blockchain. They are blockchains, they are DLTs, they have all the same things that, you know, permissionless chains can do. However, the only way businesses are going to use this infrastructure is if you have this privacy and confidentiality in place. Voting-based consensus, we're going to get into consensus in a little bit more detail, is very different than lottery-based. You're not winning money, right? You're just, you know, sometimes it's called proof of authority, though that's a different kind of consensus technique. We'll talk about them in more detail. But the thing is, you're putting your good name on the line and saying, this is either true, I'm endorsing it, or this is not true. This didn't happen, right? And so there's a full audit trail of all that information, and you're voting for leaders of consensus, and you're also voting for what took place in terms of transactions within a particular block. It's focused on B2B transactions mostly right now, but there will be B2B2C and B2C coming, you know, more as, and there will be some hybridization between these two systems, which will enable that. The other thing is you have very high throughput. So, you know, Bitcoin, Ethereum, you're around 7 to 20 transactions per second. If you're looking at Fabric, you know, Ripple, Corda, you can get thousands of transactions per second, 1,000, 1,500, 3,000, 6,000. There have been test nets that are showing 20,000 transactions per second. So you're showing many orders of magnitude of difference between these permission systems and permissionless. The scale, obviously, of the permissionless is a lot larger, but, you know, the permission systems, maybe what I like to say is you're dealing with high value, you know, high value transactions, but there may not be as many of them. It's low volume. So you want high throughput for these transactions because they're high value, but there's not so many. Permissionless, you have a lot of small transactions, so they're low value, high volume, and you know, they can take longer because it's not a lot of money in most cases, or it's not a lot of things. So let's take a look at consensus in a little bit more detail. And I really like to get into consensus because without it, you don't really have anything with a blockchain system or DLT to offer. Your system is, from my perspective, it's not very valuable. It doesn't really provide, it's only as good as its consensus. So a leader or validator is selected either by lottery or by a voting process. So you have this leader from the group of nodes. The leader makes a recommendation. I mean, if you're dealing with proof of work, that leader is the person that solves the puzzle the fastest. And then they say, okay, here's the block extension. Here's the next block. So the leader makes a recommendation for the next block. But, you know, the same thing can happen in a permission system if you're using Raft, if you're using Paxos, if you're using a BFT-based system. You will vote for a leader. The leader will make a recommendation for the next block. If you're a crash fault tolerant system, that leader, basically everything gets rubber stamped by all the other nodes. And that's an optimization, but it's not necessarily more secure. It's not necessarily more accurate. It's just an optimization. This recommendation is socialized with the other nodes. So there's different approaches to doing that. Gossip, gossip about gossip. Different approaches to socializing that information to the other nodes. It can be once, it can be twice, it can be 3 times. The other nodes either verify or reject the transactions in the block, but you know, you have to have some minimum threshold. And so if a minimum threshold of nodes verifies the block's accepted, all nodes add the block to their local copy of the blockchain, and then the process repeats. So it's actually a fairly simple process at a generalized level, but it's critical because you don't have one group that's making, you know, a commit to a database and saying, okay, this is the truth. You have a group that's agreeing on what is getting committed to the ledger, and then, you know, it has to hit that threshold. So if we look at the types of consensus and permissionless, we talked about proof of work used by Bitcoin and Ethereum. Proof of stake is the future of Ethereum. It's considered to be more fair. The problem with proof of work is it creates these hashing pools, because hash power is what wins. The more hashing power you have, so people band together, and that creates concentrations, which makes it more centralized. It also favors those with a lot of money. Not that proof of stake doesn't. Proof of stake also has the same flaw in that people who have a lot of stake actually make the rules. So, you know, you've proof of work, proof of stake. Delegated proof of stake is, you know, where you actually have a small group of delegates that get selected by everybody else. It's used by EOS and NEO. And then you have a BFT-based POS, which is Tendermint and Ontology, where you're using POS, proof of stake, but it's under a BFT paradigm. And so in BFT, it's very similar to the specific consensus. You know, choose a leader, leader makes a particular recommendation, and then the others all agree. And then there are usually two rounds. And, you know, in doing this, you have to have that two-thirds have to agree that this is the correct information before it is placed into the ledger. Because you have to vote every time, if you look at the permission systems with Byzantine fault-tolerant systems, because you have to vote every time, it can be slow, right? So sometimes people employ PBFT, practical Byzantine fault tolerance, where you have a fixed leader, and the fixed leader means you don't have to vote every time. You only vote when the leader basically goes offline. So that leader goes offline or they lose connection, then you'll vote in a new leader, and then people will agree. Federated Byzantine agreements used by Ripple, by Stellar, they actually have many, many rounds of voting, and they get up to 80%. But they also have, it's federated, so you have a core set of leaders which are known entities. So it's kind of a hybridized thing, and it increases the speed. A lot of these systems in permissioned are about increasing speed. In fact, Hyperledger Fabric, you've got an ordering mechanism which uses a crash fault tolerant system. The orderer is actually pretty centralized, you know, sending out the ordering of all of the transactions that are in a block. And so this optimization increases speed. But, you know, if you would actually do it quote unquote properly, you'd have to slow down. You have to use a BFT basis. And, you know, if you're in a permission system, you might say, well, you know, we have 30 nodes, we know everybody, we trust everybody in the system. It's not necessarily a trustless system. Let's use CFT, right? Let's use a raft for our ordering system. And, you know, possibly Sweta we'll get into this, but if you look at these systems, you know, they are really compromising certain capabilities or certain key concepts in blockchain, but the goal is try to get something as a result and not lose a lot in the process. So in the permission systems, you're trying to optimize speed, finality, and you trust your nodes. In the permissionless systems, you don't trust anybody, right? So you're trying to optimize security. So if it's slow, you just say, well, it's slow, but yeah, it's secure, and the results are correct. So, and you're dealing with money in most cases, so it's important. So these are the types of trade-offs that you often see between these systems, and that's a practical thing. Businesses are very practical. So, if we take a look at, the whole flow, when you process a transaction, this as a block representing that transaction is created. It's not exactly correct. The transaction is placed into a block. So a block is a whole set of transactions. And then that block, after all the transactions have been placed into that block in a certain time period, and there's a certain size to it. And this is a part of the scalability of Bitcoin and others, is that their block sizes are small. And this is why you've seen a lot of different systems try to increase the block size, and they create competing, blockchains that have larger block sizes. But this can be set in a permission system to pretty much whatever you want. And that block is then sent to all the nodes. Nodes validate the transaction. If it's a permissionless system, they receive a reward. The block is added to the existing chain, but it doesn't end there. You actually have to go through quite a few confirmations. So a typical confirmation cycle in a permissionless system like Bitcoin takes an hour. If you've ever sent, Bitcoin to someone else, they'll get notified within 10 minutes that they have a transaction, but it doesn't actually confirm. There's no finality for 1 hour. And because it has to go through 6 different, you have to measure the block's length, and then the longest block length, as long as that blockchain contains your block, your transaction within the block, then it will settle. So if you can see this type of a system, you're at the store and you swipe your Visa and you have to wait an hour until you know that your transaction was completed. That's not very good for business. You need something that's sub-second, right? Or at least 5 seconds or less. You swipe, you wait a few seconds, you get the approval. That's the way permission systems work. They give you finality. These systems, they don't worry about finality because they're focused on security. So if you're looking at permission blockchain systems and consortia, they look a lot like enterprise software. And so, if anybody is familiar with this, this is a standard Hyperledger Fabric kind of drawing. It shows here certificate authorities, it shows peers, which are the Ps, CAs, or the certificate authorities. You have chain code, which are going to be your smart contracts, which get affiliated to the peers. You have things called channels, which is where the peers carry out transactions with trading partners. This looks like something that a business can understand because this is the way they carry out business. But it's done in a way where you have all the things that we've talked about in terms of immutability, in terms of privacy constraints. Some of the issues that we have here is that these certificate authorities are actually centralized, which is a weak point. We can get into that in a little bit of detail later. But the important consideration for all of you is that when you're looking at permission systems, they look like enterprise software that everybody knows how to operate with, but they work with consortia. So often what you have in these systems is not just your company, it's not just your organization. You're dealing with 10, 15, 20, 30 organizations that are all sharing information. And if you're in the same channel, for example, you're actually sharing all the transactions that happen, regardless if you were part of the transaction or not. If you're dealing with Corda, it's not that simple. They have a much higher level of security. And so in the financial industry, you tend to have a lot of people using Corda for that very reason. Not that it's necessarily right or better, but it's something that they prioritize. And so you're seeing a lot of adoption because of that. So this is something to think about, when you're building it out. You do not have single node systems. You're going to be dealing with multi-node systems. And, a lot of these developer kits that go and help you to set up a node and then carry out some blockchain transactions, those are toy systems. That's not a real world system. You need to have something that's actually industry spanning. It has hundreds, if not thousands, of different players at scale, and some of those do exist in the world today. But that's, you know, some things to keep in mind. So the permissionless systems' strengths are they're proven to be secure at scale. That's something that you haven't seen yet with permissioned. They incentivize honesty, you know, with this proof of work in most cases. Transparency is clear with block explorers, or if you're a node and they're a miner, for example, and you can see what's going on. The weaknesses we talked about: low throughput, delayed finality, high energy usage if it's POW. POS basically is just, you know, it's not yet deployed because no one knows if it's actually secure. Strengths for permission is nearly instantaneous finality, high throughput, optimizes confidentiality, and the weaknesses not yet proven at scale, and they may rely on centralized systems, which means that there are flaws in the underlying infrastructure for hacking. So the components, you have nodes, a distributed ledger, consensus mechanisms, smart contracts, miners, cryptocurrency. That's what you see on the permissionless side. In permission, you have nodes, often called peers. You have membership services because you have to be able to identify and know that somebody actually belongs there, because it's not open to everybody. It's only open to a select group in terms of the peer nodes. You may have a lot of other groups that use the infrastructure, and you know that's more of this hybridized structure that I've talked about. But you know you still need to be able to identify everyone that's using the system. That's the way business works. It's distributed ledger. It's got, you know, consensus mechanisms, got privacy mechanisms like zero knowledge proof, which I'll talk about briefly. Smart contracts as well. So there's a lot of the same basic infrastructure with both systems, but you have a lot more around privacy, roles, around membership in the permission systems, because businesses need that. And they get certain benefits. So a smart contract, you probably all know what it is, but from a technical perspective, smart contracts are not contracts at all. They're not really smart, but they're just programs. You know, Ethereum, Vitalik, you know, often says code is law, right? So, you know, there's this concept that this code becomes a contract, and so it becomes law. Right? So it operates by specific rules and only if certain parameters are met. And like the blockchain, it's immutable. So it can't be modified once it's deployed. That can be a major problem, especially if there's a flaw in it, because you have to delete it, you can't modify it. So a lot of people don't realize that. They're also very deterministic. So things to keep in mind with smart contracts are use case. You have to really model the full workflow to really understand all the parameters. It's quite complex. So there's business logic. You have to determine all the actions and all their consequences. And the reason that a lot of these become vectors for hacking is because people don't do the work up front to understand the use case, the business logic. And then what are the authorizations? What private keys and parties are required? Atomicity, which means that either executes or it fails. It can't partially execute. There's no such thing. You know, either all the different parameters fall into place and it executes, or it doesn't. Error trapping, what types of actions are not allowed. And then, like I mentioned, it's deterministic. So all transactions are based on the current state of the ledger at the time the smart contract was invoked. So it's not like, you know, there can't be any grayness about the parameters. They have to, you know, be about a specific set of parameters, key value pairs, if you're familiar with the ledger structure in blockchains, at the specific instant that the invocation happened. And then, you know, a lot of these, there's this whole discussion about Turing completeness. Solidity talks about it itself being Turing complete. Chain code is Turing complete. Stellar is not Turing complete. So Turing completeness means that you can basically do anything with the smart contract code. And so you say that's a feature. But you know, it can be a feature or a bug, since smart contracts can be an attack vector. And if you look at this picture, You know, if you really just want the functionality that's in this blue inner ring, light blue, but you have, you know, the size of the feature set and attack surface of Turing completeness here, you're setting yourself up for a lot of potential mistakes, which can lead to unnecessary risk. And it's well known in, you know, the smart contract community that a lot of smart contracts are not thought through fully, but then they're replicated. And that replication sets itself up for unnecessary risk. So think about, do you want to use a smart contract language that is Turing complete or something that is more restricted? Restriction is bad in some sense if it can't do what you want, but if you can get it done and there's less attack surface, less ability to make mistakes, that might be a better consideration. Just have a couple more slides and then I'll be done with this section. But the key benefits of a digital asset are that it's easy to copy and it can be quickly disseminated widely. That's great until you start talking about a lot of things in business or talk about money. If I can just print infinite money, or if I can print infinite, you know, amount of songs or whatever, that's a problem, because now I'm basically counterfeiting, and it's really easy to counterfeit online, like we know. You don't have to make a printing press and all this, you just have to make something and then replicate it and then distribute it widely. So this leads to the double spending problem that most of you have probably heard of. There's two fundamental models, and they were, you know, brought up and created in the permissionless world, but they've been brought on into the permission world as well. So Hyperledger Fabric, as well as Corda, they make use of these UTXO and account models, because you have to keep track of, you know, something might be correct, but that transaction could have already happened. So you have to not just know that particular transaction is correct, but that it's only happened once. UTXO is stateless, so it's more private. So not surprisingly, that's with Bitcoin. Ethereum, because of the smart contract model, it has an account model, which is more global, and it keeps track of all the assets, kind of like a bank account. So it's akin to providing every global user with a global account to track assets. It's stateful, and that's really easy for, and more efficient for smart contracts, because then you can just go to the stateful account model, do one lookup, and then you can carry out your transaction. Like, does this person have enough of this asset in order to make a purchase, or does this person actually have this product that they can send to someone else? In a UTXO model, you might have a wallet, and you're going to have to go, because it's stateless, you have to look over all the different addresses that are inside that particular wallet. And so there's some math, and, you know, there's more things that you have to do in order to be able to know if somebody can carry out a particular transaction if they have multiple accounts. So these are some things to think about. Maintaining privacy, I've talked about zero knowledge proof, but because you can have competitors working together, there are things like secure multi-party computation, there's trusted execution environments, or what are called Ts. These are used, as well as zero knowledge proof. Ts are used in Corda. Zero knowledge proof is basically used in all blockchain platforms, or soon will be. But it's the idea that you can either obfuscate the parties involved, or you can obfuscate the transaction, or both. And there's still a record of it, so it can be audited, and there's a way to actually look at it if required. But inside the ledger, there's just a hash, and that hash can only be decrypted by those that are involved with the transaction. So these are very important for maintaining privacy, and not surprisingly, they're used more in the permission side. And so last slide is that the future, like I mentioned, is really hybrid. So it's not really a tension between permissionless and permission systems. You often, with your system, you have high speed with instant finality, but you also need to have a good end user experience with high transparency. And so if you look at those words, that's a combination of strengths of permissioned and strengths of permissionless. And so these conditions are really going to push blockchain architectures to interoperate and enterprise permission systems with consumer-friendly permissionless systems. So I can take a break here. I know we ran over a few minutes, and take any questions. Are there any questions? Okay, no questions. That's fine. I just need to get a drink of water. I forgot to get a glass of water. It'll just take me 1 second. So let me just pause for a moment and I'm back.
Hello, I have one question.
Yeah.
So my name is Ashutosh Kapuskar.
Yeah.
I'm from Copperwire Systems. We develop middleware for blockchain. My question is, I read somewhere that Hyperledger Fabric supports CKP, zero knowledge proof, in two aspects. One is for the ID, like ID mix, and one is for the transactions. So could you please tell me like something more about the support, like which versions provide that and where I would find the documentation for the APIs and other?
Yeah, Sweta is going to be better. It's better to ask her in the next session. Sure. But yeah, there is the identity mixer, like you mentioned. I think it came in at like 1.3 or 1.4, and then there's more of the transaction obfuscation, which I believe is in 2.0. But don't quote me on that. She'll know better. But the identity mixer was first, and then the digital asset capability for obfuscating, it came later. So high level, and Sweta can give you more details.
Sure, thank you.
Mr. Woods, this is Pramod Sarja from Paramount Software in Atlanta. First off, thanks for your presentation. It was very useful, very helpful. So you did talk about the implementation of blockchain at enterprise level more on the fintech side. So in your opinion, which industry do you think has an immediate need at an enterprise level, for the blockchain? Which industry?
Yeah, it's perfect because I'm just about to get into the use cases.
Okay, good.
So that's my next presentation, and then Whitney will be joining me. So we'll get into that, and then she'll give you some real world examples of where it's already been deployed.
Okay, cool. Absolutely. So do we stay on the same Zoom link? Or?
Yeah, just stay right here. Just stay right here. We'll just keep going. So any other questions or?
Yeah. So could you please explain the difference between, so you said the DLT is not exactly a blockchain, right?
It's a more general class of distributed ledger, but it doesn't necessarily store everything as blocks, and it's not necessarily decentralized in the same way.
Like where do you see the application for DLT as against a blockchain?
Yeah, I think DLTs are really good from a testing standpoint. It's a lot easier to deploy a DLT than it is to deploy a blockchain. Just because, you may not always have a lot of nodes, you may not always have a lot of parties, right? I mean, you have to have like a whole group. I mean, I've gone and I've helped companies test systems, and they're like, well, who else do we have join this system?
Right.
How do we work with them? How do we share information? How do we set this up? You have to go through a whole governance, discussion, and it takes a long time. If you look at most blockchain consortia that form, they can take like 18 months to 2 years just to figure out how they're going to work together. So, a DLT, if you just want to test out the tech, is a lot easier. I mean, you can obviously do like a permissionless blockchain pretty quickly, but if you're in a permission system, I think a DLT is a lot easier.
But then you will be developing it using a different set of APIs and other things, right?
No, I mean, it'll be the same. It's just going to be like maybe 1 or 2 node system, or maybe you have an organization with a few nodes. It's more centralized, right? It's not like a true, decentralized blockchain system with 10, 20, 50, 100 parties.
Then how would that be different than some of the NoSQL or the database systems like Cassandra or?
It's not very useful. It's just really for test, so you can kind of play with it. But the real power comes when you are able to share information openly across systems, and you don't have, we'll get into some of the use cases, and you'll see when you can deploy at scale. But keep in mind, these enterprises are spending millions and millions of dollars to get these things set up, and it's not cheap. It is cheap in the long term, but there is upfront cost.
Yeah. Thank you.
Sure. Okay.
I had one question.
Yeah.
This is Vijay here.
Yeah, Vijay.
Yes, with respect to performance, you mentioned you had seen up to 1,500 transactions per second. So if let's say the end user, I'm assuming, can have a laptop, and if they are doing secure transactions, how does that work? I don't know what kind of encryption signing techniques are used.
Yeah, I think, again, Sweta will get a little bit more into the actual architecture of the system and the design. And there's a lot of different design elements. 1,500 is kind of an optimized system. Usually when people build their test systems, they're usually getting more like a few hundred transactions per second, because they don't optimize a lot of things. And it's kind of a hit or miss in terms of figuring it out. If you've done it before, you can figure out how to set it up so it's more scalable. But I think that's the same for anybody building enterprise software. How many times have we built applications and the first application just not very scalable because you got, garbage leaks, or you're caching too much stuff, or you're just not optimizing. There's bottlenecks that form at different places. You've got certificate authorities, and you've got a lot of different moving parts that you've got to figure out how to optimize.
Okay, so it was under controlled testing conditions. That makes sense.
Yeah, it's tens of thousands actually. For typical, with people who have done it for a while, they can hit 1,500 transactions per second pretty frequently with Hyperledger Fabric. And I know, Corda has been shown to handle over 6,000 transactions per second, but those are really heavily optimized systems by people who are, experts, and they're very specific use cases. And so we'll get into some of those use cases. It's not like every situation and every example. But the other thing is, keep in mind, in the enterprise, you have a lot of high value, low volume types of transactions. So if you look at, some of the blockchain systems that are out there that are for logistics, they're doing maybe 1 million transactions a month, right? And that sounds like a lot, but it's really not that many transactions per day. And so it can easily handle, maybe 100 transactions per second as a peak. You're not having to deal with hundreds of thousands of transactions per second of what they do in Alipay in China when there's some kind of big sale going on. So, keep that in mind.
Thank you.
Yeah, okay, so let's get into some of those use cases so we can talk about it in a little bit more detail. Actually, I've modified the order, but it's going to be financial services, supply chain management, healthcare, and identity. So something to keep in mind is that, like we talked about this morning, there's a lot happening on the global stage. So China is saying, embrace it. You've got the California Blockchain Working Group. We had Ian Calderon, who's right here as our keynote speaker. Radhika is here. We have Ben Bartlett back there. Anyway, we got Brian Bellendorf. He's the executive director at Hyperledger. David Tannenhaus from VMware. There's a lot of people, you know, that are involved. You have Christine Lagarde talking about the, you know, the digital euro. So, you know, this is being taken very seriously by some of the most important people in the world. This is not just playing and, you know, hopefully, you know, something works. That's what I wanted to start with, that enterprise blockchain is here to stay, and it's going to become part of the fabric of our technology stack. But it's going to take some time because it's early days and there's a lot to test. So if we take a look at financial services, you know, during the pandemic, we've got trade finance issues. A lot of people don't realize until we saw it recently. In supply chains, you got a lot of stuff that doesn't make it through the supply chain, right? I mean, stores were empty, people couldn't get their PPE, and a lot of that is based on the fact that companies inside that supply chain don't have money. They're not receiving money, they're not getting money, they can't ship, they don't know what's happening throughout the supply chain. So trade finance is one area where you can actually, companies that are in the process of sending large orders can get different kinds of financial assistance from banks so that they can carry out certain transactions. If you can prove beyond the shadow of a doubt that a particular company, which might be a small company, is involved in a particular transaction, then a bank is likely to extend credit. However, if that company cannot prove that it's involved in that transaction, it cannot, and in 50% of cases in the world today, there's over $9 trillion that's stuck in supply chains. And, you know, when the world is working at scale, we really don't notice it that much because it's just some small delays. But when those delays get big, like happened in the early days of the pandemic, you see it everywhere. Everybody has nothing, right? Nobody can get anything out. And a lot of that is based on the inability of small companies to get credit. And that's a trade finance issue. Blockchain enables those companies to prove that they are part of a supply chain, and the banks for all parties involved are actually on a trade finance consortium blockchain. And there's quite a few of them that are spinning up, and it kind of greases this process of enabling better commerce. And that's why it's called trade finance. Financial inclusion, we talked a lot about it this morning, democratizing access to financial services. If you don't have a bank, you don't want a bank, excuse me, like you know, in the developing world, excuse me, then you just have a wallet. It's up in the cloud, and you can actually carry out you know, commerce, and we say that a lot in the developing world. But again, you want to make sure that there's no fraudulent activity going on, and that the information that you're seeing is correct. So again, blockchain is a good solution. It also reduces costs, especially with international transactions. And then, you know, there's a lot of government payments happening all over the world right now, and there's so many delays, right? Just delay after delay after delay, outdated infrastructure, trying to prove identity, doing all kinds of different things that, you know, there's people in the US that haven't gotten the stimulus checks from 3 months ago. They haven't been able to get unemployment benefits. I'm sure it's the same in India. I'm sure it's the same, you know, in every country in the world. So really being able to prove information and do it in a better way. And I know the Trinsic team will be talking about that more, but not just a fraudulent way of people scamming, but actually doing it in a way that is useful for people and for society. If we look beyond, before the pandemic, the big thing was removing reconciliation. So again, two banks They carry out transactions with each other. Each one has their own ledger. Each one says this is the version of the truth. There can be mistakes. There can be slight decimal differences, format differences. And then, you know, you get a slowdown in process. So why, when you trade a stock, does it take 2 days for it to settle? It takes so long to settle because you have a lot of databases that all have to reconcile with each other, and they go through a complicated regulatory machinery. How come when you send a transaction to someone on Venmo or PayPal, it takes to the next day for it to settle? Why isn't it instantaneous? Like when you send, you know, something on Ripple. It's again, because you have multiple ledgers, and each of those ledgers is shrouded from the others. You can't have all parties look transparently at those ledgers and ensure that they say the same thing. So this, when you can remove reconciliation, it reduces costs, it reduces time, and it makes the movement of money the same as the movement of information. So you send a text, somebody gets it right away. You send an email, somebody gets it right away. You send money, it takes a day, it takes 2 days, it takes a week. And it should be the same thing. The internet of money, the internet of value is possible with blockchain in the same way we move information. Cross-border payments, very expensive, slow. CBDCs and stable coins, central bank digital currencies, are ways that central banks are digitizing their monies. Stable coins are the way of digitizing fiat currencies. And then self-sovereign digital finance is really all about being able to manage all of your accounts from one place. You might have multiple banks, multiple accounts, multiple stock trading things. You consolidate them into a single wallet. So, and then you can prove your identity using your digital identity. So a couple of real world examples. So the Australian Securities Exchange is currently going through a multi-year re-architecture of its entire back end, started a couple of years ago, and it is in the process of putting in a DLT solution, as they say, but it's a blockchain-based solution or distributed ledger. So rather than having a clearinghouse and, you know, multiple entities that are all, you know, not sharing anything with each other, and then the clearinghouse adds cost and time, you eliminate the clearinghouse because they all share information directly with each other, and then your transactions are instantaneous. You can have a lot of error. In this case here, you know, append-only database, like we talked about, it's immutable, it's harmonized across all the players, all the participants can see the information. So they say that they will be saving tens of millions of dollars a year. And if, you know, this was spread to the entire industry, it would be billions and billions of dollars saved. And then, you know, whoever carries out transactions on this system, they get instant settlement. They don't have to wait 2 days, which, you know, time cost of money. You know, JP Morgan has the Interbank Information Network, which has, you know, over 300 banks. It's for making, it's a blockchain-based system for reducing errors in international money transfers. We heard from Ripple, we heard from CU Ledger earlier today. They are all working to make this transfer of money on an international basis, peer-to-peer across banks, rather than using the SWIFT you know, method that sends the information instantly, but the money takes, you know, multiple days and lots of fees in order to you know, move through the full cross-border payment process. So again, if I want to get my money from bank A to bank D, I have to go through, in today's system, I have to go through correspondent banking relationships because I don't have a direct relationship. But with a blockchain-based system, I cut out these correspondent banks and their fees and time for settlement, and I just go system to system. And that's basically what Ripple does. But, you know, there are plenty of blockchain systems that do the same thing. And this can be used for remittances as well. Trade finance, we talked about. There's the Marco Polo system, there's Contour, which launched, formerly known as Voltron, Comgo. These have all the largest, largest banks in the world. So these are real. They're being used. There's just trillions of dollars of money that can be made. It's just there's never been a way to safeguard information. Most of these are based on Corda. Not surprisingly, Comgo isn't. It's based on Quorum, which is an Ethereum-based system. WeTrade is a Hyperledger fabric-based system. So it's on all the different platforms, but you're seeing a bit more on Corda. I don't want to run that. Anyway, so there's a lot of financial services opportunities. CBDCs can help address a lot of things, but they're very centralized. Central banks like them because they want to control money and the money supply. It's not necessarily good for us because it would mean that they can see everything that we're doing at every time. It's basically the ultimate surveillance state. So, there's going to be this tension between centralized systems and decentralized systems. Supply chain management, we talked about product authenticity, a lot of reports of people getting fake products. It runs rampant, not just during the pandemic, but, just in general. Supply chain transparency, why didn't the stores know that they were going to be, why didn't the suppliers know that the stores were out of product? Because they can't see the store. Typical supply chain, you can only see one step forward and one step back, and it might be a 10-step supply chain. So you don't know what's happening at the store. You don't know what's happening at the supplier. Blockchain enables you to have full supply chain transparency because all the members of the chain are on one system and they can all see each other and see where, what product is where and, is more product needed, things like this. Rapid vendor onboarding is a big thing from IBM. You can basically get information about what are good vendors and what are not. Do they have stock? Don't they have stock? Again, we saw a lot of cracks in this whole process during the pandemic. And product provenance, once we have vaccines, you want to make sure if you do get the vaccine that it's real and you're not taking poison. So, being able to prove that that vaccine is real is something that blockchain is very good for. It also can be part of cold chains, and I'll get into that in a moment. But, basically digitized supply chains, ethical supply chains, making sure that, the products that are in the supply chain are all steps are validated. The certificates are validated. If something, you go to the store and the bananas say that they're organic because they have a sticker on it. Do you know they're organic? You spend twice as much money on it, but it's just a sticker. Anybody could place that sticker on any product. So how do you prove that that is actually, fair trade or whatever? So we usually go off the, the brand where we buy our food and say, oh, we trust them. But this is another level of trust, providing more transparency. So, there's a lot of things around food. Probably heard about food trust. It's also a Hyperledger fabric-based system for food security. Allows stores to trace any contaminated products. Where did they come from? Which farm? Usually that whole process is obfuscated because nobody shares information through the supply chain. So you have no idea where that contaminated food came from. Again, it's providing transparency to that process. So traceability, authenticity, provenance, a lot of major players, Nestle and Carrefour, Volvo working with Ford, VW, IBM, all the majors, Walmart is doing a tremendous amount in this area. There's coffee apps. So there's, any kind of product and food, you can get traceability. Cold chains, you don't just want traceability, but you want provenance, what happened, because it's perishable, right? You want to make sure that you know where the problem occurred so it doesn't happen again. You can optimize processes. So 50% of vaccines today are spoiled at the point where they're actually reach the end customer. And that's because they weren't fully in a cold chain. But you can actually monitor all that temperature, and you can place it on the blockchain, make it immutable, and now you have proof. What happens now is there's no accountability. So if somebody spoils the vaccine, they just get away with it in most cases. So that leads to rampant fraud, and it's also with food, right? Food, drugs, major issue. So healthcare, contact tracing, we heard all this wonderful things about how Google and Apple were going to do contact tracing, but nobody wanted Apple and Google to know where they were and who they were near for every second of every day. So we want a privacy preserving contact tracing app. We want verifiable credentials for testing. We want vaccines to be developed actually from all the world's companies, not everybody fighting each other and not coming up with a vaccine. So fighting counterfeit drugs, drug development and clinical trials, having a health record, personalized healthcare, personalized medication. Again, major names, Merck, Walmart, working with IBM, MetaLedger, working with the largest US companies. There's similar in Europe. All of the largest pharma companies are working on a Melody Consortium, which is all about drug discovery. So these are being adopted by all the largest companies in the world. Health records are the frontier. Aetna, Anthem, they're in the process of providing these. Walmart is joining the pharmaceutical tracking blockchain. Change Healthcare using Hyperledger Fabric says 30 million transactions per day, but they're actually doing 50 million transactions per day on a Fabric-based system. And let me just keep going. Really, in all these systems, it's not just blockchain, it's blockchain plus IoT and AI. So IoT is for more accurate data collection, AI and ML, for processing all that data, blockchain for securing it, and then self-sovereign ID can enable personalized healthcare. Self-sovereign ID is that you have individual ownership of your identity and ownership of your personal data, something we don't have when we're online. We're going to hear a lot more from Trinsic about this, so I'm not going to get into it, but this is really a cornerstone of the revolution that is coming. So with that covers the use cases. I'd like to now have Whitney come up and give us her take on all the different projects that she's worked on over the last couple of years.
Thank you, Joe.
Whitney. Okay.
Perfect. That was a very great introduction into blockchain that Jordan provided us. And looking into one or two real-world examples in which I implemented alongside another blockchain tech lead within Microsoft in Japan. So pretty much in my organization of like roughly 900 developers spread across the world, we have two blockchain tech leads. I'm one of them, and we are usually tapped to help architect like the enterprise blockchain applications. And this is like the most we will have gotten across blockchain, because I've also spent a good amount of time in the startup space. And until I did this type of work with our like large scale customers, it really made me realize how important like enterprise architecture is, like that Jordan mentioned. Like the tinkering boxes that we usually find open source is definitely not what we want to take to production. So more about me, like I said, I'm a software engineer, and in my day-to-day, I usually listen to what our customers are trying to like build for their specific industry. And oftentimes they're across like the financial, the healthcare, the retail, automotive spaces, and they aren't traditionally tech first. So that's where my team comes in, where we pretty much listen to their grandiose idea in terms of what they want to do. And then we work hand in hand to ensure that they do it pretty well, thinking from a user perspective, from an enterprise perspective. And then we sprint usually 1 to 12 weeks with the customer to bring the solution to market. So the two solutions that I will show today is actual solutions that we deployed in different pilot programs in Japan and have tested the throughput and so forth. So like I said, usually one of our customers, and they're like Fortune 100 customers, will tap my team. My team will evaluate whether this is a good project or a good fit for us to really invest our time and expertise in. And the first interaction that we have with the customer is something called the architectural design session, where we get in the room and whoever our customer is, and especially in the case of blockchain consortium, we'll have multiple customers present in the room, and we simply ask what exactly you're trying to do, what has been done, what is like the business logic, and like the different industry related stuff that we need to get on top of before we can start like whiteboarding like high level boxes of what the end solution will look like. In blockchain in particular, we see a lot of common mistakes happen in this architectural design sessions. For instance, it usually is the largest company that is like, hey, let's do this blockchain consortium. I will lead it, I will control it, and let's get to it, right? Sometimes that company wouldn't even invite the other companies they want to be a part of that consortium to the initial design sessions. And we think this is a really terrible idea because one, blockchain, as the blockchain ethos, as Jordan mentioned, is all around decentralization and like rethinking who control the concept of control. This is a collective, and therefore any attempt to take full control or apply a centralized flow to the blockchain is pretty much underutilizing what the blockchain has to offer. And a great example of this is when companies want to use the blockchain as a simple database. So I have a little animation that shows that. So the biggest company comes, they put a firewall, and in their mind, they pretty much, well, they probably don't know they're doing this, but what they do is they swap up this simple database system for the blockchain, but this blockchain is behind their firewall, and all of the other companies on the left side, as you see, now has to go through this big company's firewall to even access the blockchain. And that's pretty anti-pattern, anti-blockchain ethos. And it's just a really expensive, slow database they end up getting from this architecture. So the first thing we usually do in these type of engagements is educate. It's crazy how often we have to come in and preach blockchain first, where we are like, all companies have to be present before we could even begin like designing and architecting, far less for implementation of the solution, because everyone who will be a consortium member and also may represent a node on the blockchain has to be present initially, at least have their voice heard or like their interest in the consortium validated and enforced. Another part of this is the fact that in the world of enterprise development, every company brings their own existing infrastructure, but the only change is the fact that the blockchain nodes and system is now shared, but each party and each company still control their own infrastructure, which is then responsible for reacting to whatever blockchain events occur within the shared blockchain ecosystem. So I asked myself, why do we leverage a blockchain, especially a blockchain for consortium or permissioned blockchain? And oftentimes it's because there's a common goal. In fact, not oftentimes, all times it has to have a common goal in place to make this a valuable venture. And sometimes that common goal will be two companies, let's say company A, company B wants to optimize a process that they have happening either between company A and company B, or maybe both of them uses the same type of process, and why not come together and double down on it? Another reason for doing this is maybe company A and company B both share the same user at the end of the day, and they're putting their user first and want to create a unified user platform so that their end user can have additional benefits without caring whether it's company A or company B offering that service. And like I mentioned before, even though we introduced this shared blockchain into the ecosystem and the architecture, each company still has their unique data policies, their unique reporting needs, and even their unique development style that we now have to take into account when we enter this sort of collaborative, decentralized world in the permission blockchain. So this is some more diagrams, animations, where in the center here is our representation of the blockchain. Within Microsoft, we use the Azure Blockchain Service, which is built on top of Ethereum Quorum Ledger and uses the Istanbul Byzantine fault tolerance that Jordan briefly mentioned as a consensus mechanism. And the benefit of Azure Blockchain Service here is the fact that Azure sort of abstracts the network deployment and operations. Is pretty much like click, 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 and you have your blockchain deployed. In fact, you can deploy multiple nodes, and it even has built-in consortium management. So additional clicks, and you can add another company to your permission blockchain, as well as it has a lot of familiar development tools built in to enable you to build your smart contracts. We call it the blockchain workbench. That is a plugin you can integrate in your Visual Studio Code. But as you see here in our diagram, each node represents a company in the consortium. And as you can see, each company has like their own servers and whatever else they bring to the table. So when we look at architecture from a business to business perspective, right? Like I said before, each node represents a unique company. And you now see these Azure specific icons where this is a logic app, which is our serverless function that reacts to the events on the blockchain. And then in reacting to the event or in listening to the event on the blockchain, it's able to send reactions and trigger different actions across, let's say, their basic SQL database, their web UI, web APIs, and other functions, or maybe even like a Power BI, which is a business intelligence dashboard. And then this is like a B2C view of the architecture, where once again, we have like companies represented by a node, and ideally not one company runs the node. Maybe we have a good bit of, ideally, a good number of nodes being run independently to ensure that the network is secured. And then now our end users are able to interact with the blockchain or interact with the end solution through their own decentralized ID or public-private key pairs, in which they are able to take advantage of whatever service this consortium offers. So I'm diving into the real world examples now, but before I do, were there any questions from the first part? If not, I can continue. And I mentioned a good bit of our solution was powered by these three Azure services that I wanted to highlight briefly. In fact, my favorite is Logic Apps because this one really enables the entire scale around events within the blockchain, having to listen to it and then react to it. So starting from this end, Azure Functions is pretty much your serverless microservices that can be written in any language, JavaScript, .NET, Python. Logic Apps is pretty much a serverless microservices as well, but it's your codeless version where it's really a drag and drop screen. So you probably don't even need to know how to code to be able to enable like your Logic Apps to listen to your permissioned blockchain or even the public one as well. You can connect to smart contracts and Ethereum and so forth. And then your event grid is a simple enterprise pub sub that is able to publish and subscribe to different events between microservices. And this is really important in a decentralized world, especially because now we are dealing with multiple different services, multiple different functions, multiple different like use cases and need business logic that needs to occur post an event occurring in the blockchain. So this is a screenshot of like what that Logic app will look like when connecting to Ethereum. So once again, I mentioned there's a trigger. Usually it's a smart contract event occurs. This Logic app is set up to listen and point to a specific smart contract through an ABI. It's ABI. And once the event occurs, multiple actions can be taken that you select, whether it's to deploy a new smart contract or execute an existing smart contract function, get the state of the smart contract, or simply query a smart contract function. And of course, by now, we probably have way more actions enabled. And this is like a high level flow. So the first screenshot shows what will happen like if you trigger your Logic app using HTTP requests. So let's say your UI or API triggers a request to your Logic app, then this Logic app receives that request and based on the parameters of that request is able to query the smart contract function for a specific smart contract that's already deployed in your permission blockchain, but also this can apply for permissionless blockchains. And then whatever response you get from that query is then sent back to your original request. And another action could have been executed as well as the other 5+ that Logic app support. Then there's another type of trigger that we use in the Logic app. We use event-based triggers, where this is a feature of the event grid that I mentioned earlier, where the event grid listens very carefully to like any changes within the state of the blockchain, as well as let's say a smart contract emits the event. And from that change in state or event, it's able to take action, whether it's insert a new row in your non-blockchain SQL database, or even publish another event for another microservice or downstream microservice to consume. So I mentioned briefly that the Azure Blockchain Service enables like built-in consortium management, but in 2 ways we are able and we care about this. One is the addition of members. Like I mentioned in the beginning phase, we ideally want represented as much of the different archetypes of the companies that will be present in this consortium. But let's say not all of them were able to join, and maybe this is like a growing breeding consortium where year 1 we have these type of members, but then year 2 we are like implementing on top of that. We want an easy way to add new members, and this is enabled both by Corium and Azure Blockchain Service. And like Jordan also mentioned, a big part of this member addition, or like just the act of governance, is that you need to know who your members are. So you have your KYC, your AML, and then you have you have a need for authorized actions, and this is where the development comes into play more. So we leverage our DevOps platform, Azure, where we are able to enforce the state of the blockchain, ensuring that this is the true, trusted, canonical state, and that, let's say, none of these members randomly came in one day and made a change, right? As well as every time, especially when we're actively developing smart contracts, there may be a lot of changes, errors, especially when we are testing, right? So we need a way, and like Jordan mentioned, smart contracts are immutable. Like once it's deployed to the blockchain, it cannot be destroyed. So therefore, each time we make a change to a smart contract for our entire enterprise system, we will need to update like our Logic apps or any listeners that we have to point to the ABI of the new smart contract that we want to use, as well as like we also have built policies that sort of requires different approvals before even able to like check in or even deploy a smart contract to the blockchain. So just to summarize, we need a way to ensure that the state of the blockchain stays as is and we can forever trust. And this is enabled both by Quorum, ABS, and Azure DevOps, as well as we need to ensure that smart contracts that we're using is the most recent one and it's tested and so forth. Any questions, Azia?
Yes. Could you please explain what is ABS and what is ABI and how that fits together?
Yes. So I will send the link in the chat afterwards, but ABS is an acronym for the Azure Blockchain Service, which is
okay.
Ethereum Quorum Ledger.
Okay.
And then ABI is when you deploy a smart contract to a permissioned or permissionless blockchain, you need sort of like a reference, a pointer to that smart contract to be able to embed it into whatever additional service you want to leverage. So I'm not sure if you're familiar with, like, let's say you create a form in HubSpot and you want to embed that form in your website page. It's pretty much the code or the pointer you use to be able to point to that smart contract.
Okay, thank you.
Any other questions? Cool, I can move them then. So I will be diving into a fintech customer example. So the goal of this engagement was the fact that in Japan, we have over 200 train companies and over 1,000 plus bus companies, taxis, and so forth. So what that looked like for an end user, whether that's a tourist or just a Japanese person trying to get to work every day, is you oftentimes they will have to like buy multiple tickets or have multiple different like transit cards and load those different cards before they can even access, like, let's say train 1 to get between point A and point B, but they still need to make it to point C. So therefore they have to go and load a second card before they can make it to point C. So that was it's pretty fragmented. And at the end of the day, the user just wants to be able to get from point A to point C without caring who is providing me this service. I don't care if it's like train company 1 or train company 5. So therefore, the first goal of this engagement was the ability to use multiple of these transport services with just one ticket. And in our architecture, we used ERC721 tokens to represent this ticket, where we rolled up all of the different tickets that is needed for this specific route into one ticket, one ERC721 token. And like I said, some example services were the financial companies. For instance, we had one bank in the consortium, but let's say multiple other banks want to join. We had automotive companies that offer like car rentals or maybe just like ride share, for instance, like Lyft or Uber. We had the retail companies. So this entire project was called Mobility as a Service, and I'm not sure how much you all know about that, but it's all around unifying the mobility process that a human undergoes to get from point A to point B, but also get access to different things. So for instance, let's say I called a ride from my office to home, but I know I have to pick up groceries. So I can probably I can probably communicate with my target shop and get those groceries packaged and ready for me. So my Uber driver can just pull up, load it into my car and we can carry on home. So that's where the retail came in. And then of course the trains and the buses, and the insurance company was more of a mitigator. For instance, in Japan, they pride themselves on being punctual. In fact, like it's very rare for a train to run late. So the insurance companies now have like a business space where, okay, if I'm selling you this ticket that promises you that you will arrive from point A to point B at 8 a.m., the moment there's some form of delay, the blockchain system reacts to that and the insurance company kicks in, whether it's by giving them enough of a coupon to buy coffee while they wait for their delayed train, or maybe, especially if it's like a premium insurance service, they can provide like an alternative route, whether that's by a taxi come in and pick picking the person up outside of that latest train system. So that was the initial goal. And then, of course, across the consortium members, we wanted a way to transparently and confidently view all users' transport history. We want to onboard other consortium members easily and cheaply without having to change a lot of code, as well as the state of the blockchain. And we wanted to be able to exchange the Japanese yen ERC20 tokens to ERC20 tokens, and then of course to buy the ERC721 tickets using those tokens. So that was the high level goal of this engagement. And this is like a walkthrough of the user experience where our bank partner provided the open API and became that on and off ramp for the swap of our mass token, which is the unit of value to purchase tickets. And our user pretty much joins this, well, signs into the application using decentralized identity. And from there, we have a way of validating this is a true user through the Japanese ID system. And the data collected from the ID system is stored in that user's identity hub that is also decentralized. And then of course, at that point, the user is able to like say, this is my current location, this is where I want to go. And the system does all of what it has to do to create this ticket. So whether it's rail, bus, taxi, ticket off, and so forth. So this is like the ticket office. And then once that ticket is generated and sent to the user now proceeds to every gate entrance for the train, bus, or so forth, and able to scan that ticket to be able to get along on their way. Any questions? Okay. So this is more, this shows more of that what I mentioned. So the shared ledger was the Azure Blockchain Service, which is Ethereum Quorum. These are the companies represented, and so the user registers with the ID card and the DID identity hub. We use the Ion Test platform. And once that user inputs like their route that they wanted to go, we were able to generate a unique ERC721 token that represented all of the transfers that the user had to undergo. And then that user is able to scan the original route, so that user is able to scan at each entrance and exit. And let's say the train is not working, then we emit a new token for them to be a new ticket for them to be able to go. Let's say you get the nearest car rental, and the ticket itself even unlock the door of the car for us. And then the user could like drive to his final destination. That could be the hotel.
One question.
Yes.
So in order for this particular, so the token is on the user's mobile?
Yes. So we built it as a mobile app and web app. So I'm not sure if you're familiar with like those cross-platform frameworks like React, Ionic.
Yeah. So then when he goes to any of these, like let's say to an airport or to a bus station or train station, so they like what sort of readers they had so that the user could scan his
Yeah. So we generated it as QR codes, and each of these IoT devices were able to scan QR codes.
So they installed new devices in all those places?
No. So we actually took that into consideration. We were like, what is the standard sensors across the transit world in Japan? And the QR code was pretty standard. So that made our job easy.
But at each, so let's say at the bus stop, you know, they would be using the bus stop reader, and at the train station they would be using the train station reader, right? I mean the train system reader. So how did how could they read this one QR code in the different readers?
So let's say you said train reader, bus reader, and let's say maybe a car rental reader. The assumption is all of those readers can scan QR codes, right?
Okay.
So that's the assumption and the prerequisite. And then it's a matter of the events within the blockchain in regards to this ERC7. This QR code represents the ERC721 ticket that explicitly states that this user have access to this train, this bus, and this car, and therefore let's say the train company, the car company, and the bus company, their external systems that's outside of the blockchain is expecting this user to come because of the events that will have been triggered.
Okay. So basically all those transports systems, they adopted this particular application or this QR code.
Yes, and if you recall, each one of these partners were present from the day one. So if they had a program with QR code, they would have spoken up.
Okay, cool. Thank you.
Yes, no problem. So that was like a high level overview of the architecture and like the end solution from a user perspective. So this is one example. I took some screenshots of our smart contracts that we use in this project. So we named our ERC20 token Mass Coin, Mobility as a Service coin. And as you can see, we built on top of the Open Zeppelin standard, and we grabbed the ERC20 that they defined alongside like the ability to mint, burn, pause, and add detail to the contract, to the coin. So this is like our, I guess, token definition that will then mint how much ever coins we can have, providing yen comes into our system. And if you recall, the bank in which we partnered with, they provided that on and off ramp from yen to Masscoin. If no questions, this is a screenshot of one of our ERC721 tokens. This was the mass ticket. So as I recall, if you recall, one of our criteria was to have one ticket representing all of the different like transit providers or route switches that needs to occur. So we built our mass ticket on, once again, the Open Zeppelin standard, which is the best recommendation on how to build smart contracts. And we made it enumerable. It had a minter rule. It had a good bit of metadata. And if you can see the different functions, we have way more functions, but the ones that I highlighted was the ability to mint a new mass ticket. So anytime someone, let's say the user inputs their destination and the system, the application logic calculated what are the different transport providers needed to get that user from point A to point C, then the act of minting this token on behalf of this user will give them assign that user the ticket that will get them from point A to point C. And then of course, we have other functions that will enable compliance, like get ticket detail by ID, as well as like how much tokens a specific owner owns, and so forth. Any questions? Cool. So a high level application flow. So everything was built, well, the application logic is a mobile and a web app. And then, of course, we had to associate the web app to the logic apps that is connected to the smart contracts. So for instance, let's say the function charge within the web app was associated to a logic app we created that is specifically API get ERC20 token that is connected to the smart contract in the consortium blockchain that is responsible for returning the ERC20 token. Does that make sense? And then the next one will be gate simulator, which will be that QR code scanner, where this gate simulator function is connected to the smart contract within the consortium blockchain that, and the logic app is named in and out of the station. And of course, this will take care of the logic of this user with this ticket came in at this time, and therefore probably can't come back in unless they buy another ticket.
So these are different apps in different locations.
So this is one end user application. And if you recall, I went through the logic app, which is like microservices in the cloud. So these are like we had to create a lot of instances of microservices to point to the smart contracts on the blockchain. So we have multiple logic apps / microservices.
And where are the smart contracts? They're not shown on this diagram, looks like.
No, but it's pretty much similar to.
Okay.
Yeah. And another big part of it, the biggest bottleneck was the gate simulator. Like whatever the transit company had to use to like admit a user in and out of their, like, I guess, transport. This is like an IoT device. And a big part of blockchain is like, what do you store on the blockchain, as well as like how quickly could you get data to the anchored to the blockchain. And let's say an average train station in Japan probably sees millions and millions of users coming in and out of their gate in a given day, right? So we had to implement a solution such that we wouldn't be kept back by the anchoring of the data on the blockchain, as well as we do it in such a way that we are pretty sure that the data doesn't change while waiting to go on the blockchain and so forth. So I'm actually going to share my GitHub repository with this open source solution in it. But the IoT symbolizes one of those gate simulators, or the thing you have to tap. Then the event hubs is like a ingest for IoT data. And then we have a timer. Let's, for instance, let's say every minute we want to aggregate all of the IoT data that we receive for coming into this gate before adding it to the blockchain. So therefore, every minute, all of the data that sits in the event hub is created, we create a blob with that, and it's an immutable blob, which is a feature of one of our storage accounts in Azure. And once that immutable blob is created, we had an independent logic app that will then hash this blob and anchor it to the blockchain in its timely manner.
So the question is, the actual transaction, is it taking place when the user's QR code? So let's say the user has his QR code on the mobile, right, which represents his the value of his token, and then he goes to the train station and he's entering the gate, and there the train system reader will scan his QR code. And okay, so the transaction is not taking place on the blockchain at that time, right?
No. So what we do here is we use our services that are architected for high frequency data to collect that scan, and then we store it in a space, a really secure space that we can then put on the blockchain, because the efficiency of the blockchain is not necessarily trustworthy at this point, because we wouldn't want the user waiting for the blockchain to give a response to that user before actually able to walk into the train.
Okay, so so it's like, it's not checking if the user actually has sufficient balance or anything. It's just like a recording that the user is entering here, and then later on it is doing when it hits the blockchain smart contract, it is doing that type of reconciliation, like essentially moving money from the users.
Yeah.
Okay.
And as you recall, the biggest advantage of adding this user data to the blockchain is for all the companies within this consortium to be able to see the user transport history in a trustworthy manner.
And how frequently this hash blob is getting stored on the blockchain?
So I designed it for 1 minute, but of course that's flexible based on the company desires. And once again, this event hub, this IoT gate, this logic app is within one company external system.
Right. Thank you.
So that was the first example. The other one is a cold chain example. It's the food traceability problem we're all trying to solve, where we want to ensure that from the moment of inception to the moment we get it on the shelves in the grocery and in the consumer hands, we can guarantee that this is compliant in regards to there was never a moment that temperatures drop below what it should. and therefore put the food at risk and so forth. So the overall goal of this specific engagement was to enable food traceability, control the scope of disclosure. And this one specifically is around the fact that we had different company types. We had, like, let's say a farmer, we had like a grocery, we had like the driver and so forth. And we wanted to ensure that, let's say, the driver only saw the scope that they needed to see, which is who am I picking up from and who am I carrying it to? And the same for the grocery and so forth. And then another big part was real-time remittance, where we wanted to increase the time in which a farmer can get paid, because it takes them a good bit of while before they can get like their profit from the produce they sell to markets or groceries and so on. And we wanted an overall streamline billing and payment operation system. So like I mentioned, the farm producer, they kick off this process the moment that they have a package ready for sale, where a really big thing to mention in this architecture was we leveraged the IPFS network, which is pretty much decentralized data store. And we did this for like the cold storage data, because a big thing that comes up in terms of scale of blockchain is like how much data can truly be stored in the blockchain. And for us, we decided that the cold store information, especially, it's pretty much a really long JSON file that needs to keep track of a good bit of movement. All of that data probably shouldn't be stored in the blockchain. So what we ended up doing is hashing it on IPFS network, which is also decentralized and can be trusted. And then the link that we have to that specific IPFS record, we were able to connect to in the blockchain smart contract. Any questions there?
So who guarantees the integrity of IPFS? Like your file is on the IPFS, right?
So IPFS is actually a permissionless decentralized network. So around the entire world, a lot of different persons secure in this network.
So it's like a DLT?
Yes, I guess.
Okay.
If you don't want to get too technical, yeah.
Okay.
And like I mentioned, this was like the part where we connected the cold storage data that's within the IPFS network to the smart contract that all of the businesses within the consortium still needs to grab the information from the cold storage. So if you look at this line, we have a function like get IPFS URL by package ID. And so this is pretty much, we will take in a package ID and we'll be able to return to whichever system needs that, the actual IPFS URL to then maybe go download the contents and so forth. Same with the set IPFS URL. So it's like, this is the package ID, this is the IPFS URL that keeps track of this package ID transit information, and let's store that on the blockchain. And yeah, this is more overview. We also have like a unique ERC20 token to enable this ecosystem. I saw a trend that in most consortium, we usually create our own token to represent the value, the units of value that makes this ecosystem run. But of course, that's not like a must have. And the different players would supermarket, the middle trader, like the initial trader, even the Japan agricultural cooperatives, and then the farmer, of course. And once again, we had IoT sensors involved, the end consumer who will want to like check, like let's say the end consumer in the grocery, before they pick up this apple, they probably want to scan whatever code we put on the apple to see its like travel history and like where did it originate. And so this is like the traceability flow. It came in, so this is the farmer creating the new product within the ecosystem to be able to sell. And then of course, along the way, it's checking like the the data needed, the cold storage data, and then of course it's emitting an event when this specific package leaves this specific member's hand. Then in the courier, same, it comes in, an event is emitted for in, then the checks, and then out, and then of course as it changes hands until we get to the supermarket and being sold. And this shows you the connection between the ERC 721 ticket, which represents this specific package, who owns this package, and of course points to the IPFS URL that has the cold storage data. And overall, the technologies we adopted in this project was Azure Blockchain Service, IPFS, Key Vault, which is pretty much like a secret store, Logic Apps, Azure Functions, SQL Database, Visual Studio Code, Truffle, which is the best development tool out there, in my opinion, to develop on blockchain or to interact with blockchains, and Azure DevOps.
Great. Well, thank you so much, Whitney. It's cool because, you know, when you're using Quorum, you get access to the Ethereum ecosystem. And so you have, for example, out of the box, the ERC 721, which is non-fungible tokens. So you can keep track of unique items, right, that are going through like unique tickets, or, you know, for a particular customer, or a unique good. So that's kind of cool. I've tried to do similar things in other ecosystems. It's a little bit trickier because the identity, I mean, you bring in Indie and stuff like this in other ecosystems. Like if you're on the Hyperledger platform, maybe we'll hear a bit from Trinsic about that. But thank you very much for all that.
As the world reopens, ServiceNow is helping customers make sure going back to the workplace works for everyone. Introducing the Safe Workplace apps and dashboard. 4 apps specifically designed to help ensure the health and safety of your workforce and workplace, all housed in a single dashboard to give you a comprehensive look into everything you need to know. And they're available now, out of the box, powered by the Now platform. Get a bird's eye view to make sure your employees are prepared and ready to go back to the workplace. Manage inventory levels across your organisation thanks to workflows that automatically replenish supplies. Screen and verify the health of your employees, and help manage workflows for cleaning, sanitation and safe distancing for employees. 4 essential apps, 1 comprehensive dashboard. Together we can make sure going back to the workplace can work for everyone. That's the power of the Now platform.
And let's transfer over to the Hyperledger ecosystem. And so, Sweta, if you could get us kicked off and tell us a little bit about Hyperledger Fabric.
Absolutely. Is my screen showing up?
Yes.
Perfect. So I'll go. I won't really spend time to introduce ourselves because we did that at the beginning, but if you weren't there at the beginning, very quickly, my name is Sweta. I work for Google, but I previously worked at IBM, and that's kind of the reason I'm involved with Hyperledger and Hyperledger Fabric. Morgan, do you want to quickly just say hi?
Yep, I'm Morgan. I work at IBM. I do containers and Hyperledger and blockchain and containers. So.
Awesome. So I want to start off and talk about Hyperledger in general. It is a open source foundation. It comes under the Linux Foundation. It's one of the fastest growing projects in LF history, which has been very exciting. It kind of comments to the interest of blockchain in general. The real main goal behind Hyperledger is to kind of have a collaborative environment and kind of foster that collaboration between different people, whether those are people who are building platforms, whether people with use cases, and kind of bring them together to create blockchain solutions. And what we consider the projects that come out of Hyperledger, we kind of consider them as our greenhouse. We have what we call a modular approach to it. So as you can see, these are our current projects. We have distributed ledgers. That's kind of that top block at it's the top block. Then we have libraries, we have tools, we have domain-specific things, and we also have something called Hyperledger Labs, which is a lot of kind of projects that are in the very early stage that haven't quite formulated into something that can be full-blown. There are usually a lot of experiments going on in there. Some of them are kind of like add-ons and extensions to the projects that already exist, but they just needed their own little space to develop. So as you can see, this is what Hyperledger has become. When it started off, Hyperledger was actually the name of the fabric of what is now considered Fabric. IBM had worked on this, and then when they decided that it was kind of at a stage where they wanted to take it forward, they wanted to make sure it was in open source. And I think Jordan did a really good kind of gave the good context at the very beginning, talking about how blockchain and open source are really perfect for each other. And the designers of Fabric kind of felt the same way. So they worked with the Linux Foundation and created Hyperledger. As you can see now, the projects have grown. Fabric is only one out of the 6 ledgers that we have. Some of the others that I want to kind of just quickly point out, one is Hyperledger Besu, which is the one all the way at the left. That is our first Ethereum client. So all the other platforms you see here, they would not work, or they cannot interoperate with the Ethereum-based network, or any Ethereum-based network, and definitely not mainnet or testnet or any of that. Besu was unique, and it's kind of our first project that actually can interact with mainnet. They also have options to create their own permission networks and things like that. Another one that I do want to point out is Hyperledger Indy. This is a very interesting project because it's focused on decentralized identity. This is also the foundation, and this is the platform of the Sovereign Foundations network. I think the next session will kind of talk more about it, but I just wanted to kind of point them out. Some things that came out of the Indy project is the Hyperledger Aries, which kind of focuses more on wallet support. And then you also have Hyperledger Ursa, so these both are in the libraries. Ursa is more of a cryptographic library. And kind of the concept behind all these projects is they start out like this, and then they start trying to break out pieces that can be shared amongst the different ledgers. And with the idea being that if somebody came in and looked at Hyperledger, they're able to build a network in the way that they want, using the libraries, the tools, and the platform that they desire. And then, as I kind of mentioned, Hyperledger has been growing quite a bit. It's 4 years old now. We started with 1 project, now we have 16. We have meetups all around the world. Most of them are now virtual because of the current situation, which in one way is very nice, because what it does is it opens the door to having a lot more speakers, being able to talk in different places. So I really highly recommend looking and seeing what meetups are being run, because you can now see what's happening across the world. We have a very active community. We have working groups and SIGs. So we have things that are focused on healthcare, the fintech. I believe there's also stuff about food trusts. So there's a lot of different areas you can go and talk about, and these are all in the SIGs. We have working groups that are going around architecture and things like that. And then we also have training and certification courses. So there's a lot going on at Hyperledger. If you're interested in blockchain in general, you want to contribute, you want to be active, or you just want to learn, this really is a good environment that I recommend you check out. We have some links at the end to tell you how you can get involved or how you can learn more. So with that, the more main focus of why Morgan and I are here is really to talk about Hyperledger Fabric. There are a few versions. What we're going to be talking about, the architecture and everything, is going to be a Fabric 2.0 based architecture. 1.0, a lot of the things we talk about now will still apply to 1.0. There is an older version, 0.6, which is quite old now. Most of what we say today does not apply to that network. So if you ever see something like that, I wouldn't recommend keep continuing down that path. It's very outdated at this point. So just a quick overview about what we consider Fabric is. I like to always start off with the level set of why Fabric exists and why it's designed the way it is. When the designers were kind of looking at solutions for enterprises, they kind of saw out what were the options out there. And I believe at that time, Ethereum was kind of the big option, and it didn't quite have all the requirements. And Jordan kind of gave you some of those ideas about privacy and confidentiality, finality, all of those elements that were kind of needed for enterprises to be able to adopt this technology. So Fabric was kind of our solution to that. It was designed with businesses and enterprises in mind. So the idea isn't necessarily to revolutionize or change the way business is done, but really to build upon business relationships and how business networks already exist. So the goal is to improve and make those more efficient. It is a permissioned system. When we talk about permissioning, we're talking about permissioning at varying levels. So there is permissions in terms of who's allowed into a network. We also have permissioning in terms of who's allowed to run a transaction, who's allowed to run a smart contract, who's allowed to read the data, who's allowed to submit data. So there's a lot of granularity there in the terms of permissioning. One important feature is finality. Finality is important in certain use cases. So when a transaction is made and added to the ledger, there's no chance for it to change in the future. Fabric is highly pluggable. It's also very extendable. There's a few key places. One is in terms of identity. One is also in terms of consensus. I'll kind of go through that in just a little bit. But the caveat being that with a lot of this pluggability and flexibility, the system is more complex. And it does mean that you have to be thorough and understand why you're doing what you're doing. Fabric does support smart contracts. So out of the box support comes for Golang, Node, and Java. I'm going to use the word smart contracts and chain codes pretty interchangeably. Chain code is just what we call it because that's kind of what we see is happening. We're running code on the chain. But those are the languages that we do support out of the box. As I kind of mentioned in our introductions earlier, Morgan and I have worked on allowing Solidity smart contracts or a Viper and EVM-based thing. We also had an intern last year that started up a Hyperledger lab in getting WASM support. So there are other options out there and a lot of extensions. And it kind of goes back to that pluggability and extendability of Fabric. The final thing that I think is very important to understand about the Fabric architecture is this execute, order, validate architecture. Most blockchain platforms currently, they follow an order, validate architecture. What that means is transactions are ordered and then they're validated. Or actually during the validation, they're actually executed at that point. Fabric doesn't operate like that. The transactions are actually executed first, then they're ordered, and then they're validated. And that's a very different, it's very unique to Fabric, and it does have, causes some nuances in terms of the transaction flow. I did forget to mention at the beginning, if you do have questions while anything comes up, please feel free to put it in the chat. Morgan's going to be monitoring that and trying to answer, and then he'll also interrupt me if there's something that I can address, because I know we're a little bit over time already. So I'm just going to try to move on pretty quickly, but I will try to stop in different places for questions. Saying that, any questions so far? Cool, okay. So let me just start off and let's talk about the entities, what are involved in a Fabric network. We have our CAs. These are basically our certificate authority. Default one that comes with Fabric is what we call Fabric CA. This is going to manage basically all the user identities, the node identities, ordering identities, everything. And this is also pluggable. So if you want to use a different signing algorithm, you want to use a different encryption, anything that you want to do, you can do it. It is pluggable. And there are a few different things out there that are not just from Fabric. I'll discuss a little bit more about the role of Fabric CA just in the next slide. The next thing I want to talk about are peers, which is the one below. This is kind of what you would consider a typical node in a blockchain network. This is the node that will execute smart contracts. So they're the ones that actually run the transactions. They also have a copy of the ledger. And this concept of endorsement, peers endorse transactions, and you're going to see why that's important in just a little bit. But this is kind of like our execution node. Then on the top right, we have orderers. Orderers are, like the name implies, they order our transactions. So they take in a lot of different transactions and they determine a block. They actually do never look inside of the transaction. So there is no optimization that's done based on the transactions that come in. It's the job of the orderer when they formulate a block to broadcast it to all of the peers on the channels. So a channel, I'm going to talk about that in just a little bit as well. But it's kind of like a one-to-one as a ledger. You can think of a channel as its own blockchain network, and you can have peers on different channels. And I'll have an example that will kind of clarify what that means. Essentially, channels are connected to an ordering organization or ordering system. An order organization is typically made up of multiple orderer nodes. We have different consensus algorithms that we use in determining which of the orderers in that org will be active in creating the block. We have Raft currently, that is what is supported in 2.0. In previous versions of Fabric, we've supported Kafka. Raft is crash fault tolerant. It is not BFT, and it is, the other ordering nodes that are living are usually there for availability and nothing else. That consensus, though, is pluggable. Raft was actually one of our biggest tests to see how pluggable and how good our API was in terms of that. Currently, there's a PBFT algorithm that is in the works, so hopefully that will come and kind of extend the options for our ordering organizations. And last, I want to just talk about our users. So users are kind of like people like you and me. They can be admins. They can just be people who are submitting transactions. These are the people who actually approve smart contracts. They run transactions, and they do all of this using what we call the Fabric SDKs. Currently, the two kind of popular SDKs are in Go and in Node. So the next kind of big thing that we need to talk about are organizations. And organizations are kind of like a participant in a network. You can think of it as kind of company A, company B. We consider those as an organization, and they're defined usually by what we call a membership service provider, or an MSP. The MSP is basically controls identity and kind of says these people, these peers, these users, these orderers, and this CA belong to this organization. And a Fabric CA usually is the one that is issuing new certificates with this organization's root CA. So every entity in this network will have an X509 certificate, and it will be signed by their organization's root CA. And that's how it determines which MSP a user, a peer, or orderer comes from. MSP, you're going to see it kind of pop up constantly. This is also very pluggable, so you could have your own way of how you want to define identity and manage it, how you want to pass out certificates. The idea being each organization has their own MSP, and then all they provide is a root CA or a way or a mechanism for other people to know that a user or a peer is allowed or is coming from this organization. And you'll see that in the example that I have. The next thing I want to talk about is a peer. A peer, as I kind of mentioned, has two main functions. One is keeping a copy of the ledger. When we talk about ledger in Fabric, we actually have two components to it. So one is kind of the more traditional blockchain. It's actual blocks with the hashes. There is a copy of all of that that will be stored. For optimization though, so if you had forwarded through all of the blocks from history and you see what the current world state is, we also keep track of that in a key value store. And that's purely for optimization. But if the key value store was destroyed or anything, using the blocks, we could recreate it. The other key thing that a peer does is execute smart contracts. And this kind of coloring that I have here is to kind of give you is to do with channels. And I'm going to talk about channels in the next thing, and this kind of this intro to that. Channels, as I mentioned, is kind of like one-to-one with a ledger or a network. So in this case, you can see that this peer has 3 different ledgers that it is maintaining. And the color coding is kind of to represent like this smart contract belongs to this ledger. And that's kind of what this is looking at. So you have smart contracts that will operate on the ledger that is on the same channel as it. And to kind of give you a clearer example of what this is channels are kind of, as I said, a network in and of itself. So you can have multiple orgs, and orgs are allowed into a channel. Once an org is into a channel, you can add your peer nodes to it. And not all peers in an org need to be in the channel. So for example, you can see org 2 is participating in channel 1 and channel 2. So the channels are these kind of, I've designated it with these lines over here to kind of give you an idea of the ledger. And you can see that the purple is connected to the purple ledger, the magenta is with the magenta ledger, to kind of give you an idea. You can see org 2 is part of both of them, but only one of its peers is actually having the data or the ledger for both. You can see org 3, both of its peers are connected, and it has the ledger on both. So the next thing that is important to understand with channels is smart contracts. Smart contracts are installed once per peer, but they're also instantiated per channel. So now let me give you the difference. For example, maybe I am company A and I have many clients and I have the same contract that I want to deal with all of these clients. The thing is, I don't need my clients all to be using the same ledger. So I'm going to differentiate them by creating different networks with each of them or different channels. So on my peer, I only have to install the smart contract once, but I would have to instantiate it on each channel. So that way I have multiple copies of it running. And an example of that is in here is like org 3, you can see that it's on both channels and it has the smart contract for both channels. Versus everywhere else, the peer is only running one instance of the smart contract. So I said a lot. I'll take a moment. Any questions? Okay, moving on. So the next thing that's really important to understand about Fabric are policies. Policies kind of govern everything when it comes to Fabric. When organizations come together and create a consortium, they agree upon a set of what we call endorsement policies. And these govern how they deal with network changes. So whether that's about how many people are needed or have to approve a transaction, how many people need to say yes to add a new organization to the channel, how many are needed for us to instantiate a new smart contract, what is considered a valid transaction. These are all determined by the policies that are kind of created You start with the Genesis block with an initial configuration, and you can always edit it by adding more transactions to the chain. In all of these policies, it's all rooted in terms of organization MSP. So again, that identity is very important here, that organization's root CA is actually put in that Genesis block that says these organizations defined by these root CAs are allowed. And this is how peers that might not know about peers in another organization can recognize and accept requests and accept information, because these root CAs are already in the blockchain. So I'll try to give a slightly more concrete example. Hopefully this will kind of clear up and kind of connect all the things that we've been talking about. So we're going to start off with 3 orgs. Each of them have 2 peers, and then we have an orderer organization. So I kind of mentioned that these orderer organizations are composed of multiple orderers. And this is a little bit of a remnant of when Kafka was the supported and main ordering or the consensus algorithm. During that time, because of Kafka, having orderers kind of split over subnets wasn't very practical, and it kind of affected how the orderers were working. So the recommendation always was to have all the orderers in a single organization. But with the Raft implementation, that is no longer as required as it was before. This is still kind of the design you will see, but perhaps with the Raft change and PBFT, this will change in the future. So let's say that org 1, org 2, and org 3 come together and they decide to create channel, and they decide that they're going to work together, and they have created this channel with this orderer. So remember, an orderer can be managing multiple channels, but each channel is connected to a single orderer org. What that means is the orderer has to keep track of who are all in each channel. And because consensus can be changing, for example, you can have Raft, as I said in the past, you can have Kafka, you might bring your own consensus algorithm. It's essential that a single orderer org, which has that consensus algorithm, is the only thing managing that channel. So we have now our channel. We want to run some transactions. We want to submit transactions. To do that, we need a chain code or a smart contract. So I have the endorsement policy on the top right, and in our situation right now, I'm going to say that the endorsement policy is all must approve. That means org 1, org 2, and org 3 all have to say yes for a smart contract to be accepted for this channel. The first step is admins of the organizations that want to run this smart contract are going to install it on their desired peers. So let's say org 2 is more of a, they just want to see the transactions. They don't really care about executing, they just want that ledger. So they're not going to install it. But org 1 wants one on its peer, and org 3 wants it on both of its peers. So you can see that it has to be installed on these 3 peers. Then, because this is where the endorsement policy plays in order for this chain code to be run, an admin from each organization needs to approve the chain code that has been installed. And when you do that, you're actually going to be able to see, okay, org 1 installed this chain code, org 3 installed this chain code, and you can see that and you would approve and say, okay, I'm okay with this. When all 3 of these have approved the chain code, one org or one representative from an org needs to instantiate the chain code. So they submit a single transaction, which causes the smart contract now to start running wherever it's been installed. So all of these steps that I said are actual transactions that go into a block on the same, on the channel in the chain. Let me pause there. Any questions? Cool. Now, a little more exciting, and probably what you're more interested in, is how does a transaction actually work? So I use, again, the important thing to always remember is the endorsement policy, org 1 and org 3. So remember, org2 doesn't care about execution in this situation. They only want to see the ledger. You could see that there would be a problem though if the endorsement policy was all must endorse. And you'll see why in just a second, but the general idea is org2 isn't able to run the smart contract, so they would never be able to endorse any transaction. So the first thing is a user will create a transaction proposal. This is essentially, I want to run this function on this smart contract, and there might be some input values, maybe not, and they're going to submit it. So you can see that since it's org1 and org3, in org1 there's only one option, one peer that the user can send it to. In org3 there's two, you can just pick one. It really doesn't matter which one a user picks. This is the time where the peer does the execution. And they'll execute, and what they will take note of is two things. One, what is the read set? What keys are being read and what are their values? And then the next thing is the write set. What keys are being written to and what are those values? And the peer is going to endorse that, which essentially means package it up and sign it saying, when I ran this transaction, this is what I got. The user is going to collect all of that, and usually this is a good time to just check and see that all the endorsements are the same, essentially that the smart contract has the same result everywhere. This kind of goes back to what Jordan was talking about in terms of deterministic smart contracts. Your smart contracts can't have elements of randomness or anything because the output of those transactions would be different. And that kind of makes the case of an invalid transaction. So saying that all of them are the same, the inputs and the outputs are the read-write sets, the user now will broadcast this transaction with the endorsements to the orderer. And you can imagine that other transactions are going around in that channel, so the orderer will be getting other transactions broadcast to it as well. The orderer will take all of these transactions and formulate a block. All they're going to do is determine the order. It will not look inside of the transaction. It won't do any kind of optimization, nothing like that. Once the order has been determined, the block is formulated, the order will then deliver it to all of the peers on the channel. And that includes, the two peers in org2, which are part of the channel, but they never ran the transaction. Then the next step is the peers add the block. So no matter what happens, the block will be added to the chain. It will also validate every single transaction that is in the block. What that means is it will go through and verify the read-write sets. It'll make sure that the endorsement policy has been met. It checks that the read-write sets match. And this is the third part, which is very key, is that the read set matches the current state. If the read set doesn't match the current state or any of the other conditions I just mentioned, the transaction will be marked invalid. It's just like a bit on the block that says this transaction was marked invalid. If the transaction was marked as valid, then the world state will be appropriately updated. And as you can kind of see, the block is now added. An important thing here is to understand that no matter what, invalid or valid, there is a record of the transaction being made. It will still be on the ledger and it'll still be there. Another thing to understand is with this model, when you have transactions that are operating on the same keys, you could have collisions. So essentially, if you have two transactions that are trying to read and write to the same key, only the first transaction will be successful. Because the first transaction will change what that initial state is. So if the second transaction in the same block is trying to edit that value, its initial read is no longer going to match what is in the world state. And because of that, the transaction will be marked as invalid. Any questions? Okay. With that, I'm going to pass it along to Morgan, and he's going to.
I have one question.
Oh, yes.
So on the previous slide, when you show the user sending the, the transactions to peers and then to the orderer, by that you basically mean the client application, right?
Yeah, we do. Yeah, so this is all being done using the Fabric SDK. How that is actually done is kind of based on how the user, the application is built. Yes.
Okay, so that piece is actually sending things to peer and orderer.
Yes. Yeah. So all of this can be generated.
Okay.
Yeah, but if you consider it, the application and the SDK is kind of more of outside of the network. How this is done is like not part of the Fabric architecture. We do have a way, which is through our SDKs. You can build applications through that make it very easy to submit transaction, and it automates this logic to figuring out which peers do I need to submit to for the endorsement policy. So usually in an application, it'll be like pressing a button or, adding some inputs and pressing send, and then the application will take care of this kind of finding the right peers, getting the endorsements, and sending it to the orderer.
Okay, thank you. And one more question is, so those the transactions for installing the smart contract and instantiating, right, chain codes, those are they only available in the CLI, or is there like a JavaScript and Go APIs for them also in the SDK?
I can't remember if the Golang SDK has already updated to Fabric 2.0. I think they have. The Node SDK, you can definitely do it. So these are not necessarily pure CLI. I'm guessing that's what you're referring to. Yeah. Most of these can be done outside of the pure CLI.
Okay. And okay, one last question, which is actually the question that I had asked in the beginning, and at that time, like, we decided to wait for your presentation. So there is a zero knowledge proof support I read in a document, right? So there are two types of zero knowledge proof APIs. One is for the ID mixer for the identity, and the other is for transactions. Could you please tell a little bit about if those are actually available in 2.0 or 1.4, the APIs for transactions and ID mixer both separately?
So ID mixer is there, I believe, starting in 1.3 and is also there in 2.0. In terms of transaction support, that's kind of still in progress. There hasn't been anything that's been established as the way moving forward. I might be wrong, but I believe that is the current state right now. When we talk about zero knowledge proof, it's still focused on the identity mixer.
So for the transaction, is it like even available in, let's say, not in the actual version, but in some sort of like
I can't remember exactly, but I believe that there is some work that is in one of the Hyperledger labs for it.
Yeah.
There is a lot more, I would say, white papers that have come out in terms of what they want to do, but nothing has been finalized in terms of what has gone in code-wise.
Yeah, that's what I thought. Okay. All right. Thank you.
No problem. Any more questions before I kind of pass it on to Morgan? Okay, Morgan, all yours.
All right, button, share. And hopefully desktop, terminal. And you can hear me?
Yeah.
Okay, excellent. So I'm going to do a demo similar to what you sort of saw in the slides there, a little simpler, just to show you what's running. I'm running sort of one of the basic toy examples, but it will illustrate our points very well. How do I get this to go away? Okay, and so what we have is we have two nodes. We have two organizations. Each is running one peer. Each of them has their own CA to manage as an MSP, to manage the identities for the particular organization. We've got one shared order, doing the, I think it's single node raft. And then we have these CLI containers, which are just useful to get us into a pre-configured shell so we can interact with the peers on each org. And we're going to use peer CLI. So if you're already familiar with this, then it might be kind of boring, but let's get started by first understanding where we are. So I've got two, and the same rules apply here. You know, ask questions in the chat, and Swetha can interrupt me if that's necessary. But to start with, we have, I've got a CLI in each of the peers, and then I have a log endpoint for the order and the just one peer, because the peers are going to do the same information. Back up a little bit to understand when we talked about the setting up of the network. So I started this up automatic already, but the actual setup is I want to take a quick look at, so just so we understand how the network is built up. And like most blockchains, that we have a Genesis block that we can configure everything into, and then we will put more information into that blockchain and build it up before we even start any of the peers. And inside of that Genesis block, we put the configuration. And so you can see we start with a Genesis block, and then again, we started, what's the core ledger sort of identity within Fabric? It's a channel. And so we create a channel and make a transaction that will operate on the chain. And so we generate these transactions that say, okay, we're going to have a channel, we're going to have org 1 on the channel, and then we're going to have org 2 on the channel. And then we run these transactions against the Genesis block, and sort of have a minimal Genesis chain when we start up. And so we can see here that, oh, not that one, this one, we can see here that we've already got a couple of blocks created. We have block 1, block 2, and that is basically, those exist because the configuration of the blockchain in Fabric is on the blockchain itself. And so this is an important, for enterprise kind of management idea, that the blockchain is itself involved in its own management. Okay, so once we have that, we have to package some chain code. So I've mounted into each of these CLI containers the basic chain code. I can pull that up really quick. And it's the basic FABCAR chain code, and it contains very few sort of interactions. One of them, which is init ledger, which just dumps a bunch of information into the chain to start when it starts up. One of them's query car, which lets you, so this is a FABCAR, Fabric car. And so what it is a sort of I hesitate to use the word, a little database of cars. And so we can query and create and move them around. But that exists, and so we have the JavaScript version here, and so that is what I'm going to create. And so I've got it mounted at this opt GitHub chain code JavaScript, and I'm going to run a peer command, peer lifecycle. So again, chain code has its own lifecycle where you manage it, and what part we want to do now is we want to package it, and we want it to end up in FABCAR JS gzip. And we want to give it a label. And the label is one of the important things that's going to have to sort of match up over time. And so if we look, you can see that we have the FABCAR JavaScript chain code. And on our other peer, we don't have it. So I'm going to do I'm going to copy it. I'm going to do the same thing over there. And so now we have the same chain code packaged up in the same way as a tar gzip. And so that's actually an important thing to understand in terms of packaging. Packaging chain codes used to be kind of a pain in the butt because it was sort of a proprietary, weird format involving the protobufs and whatnot. But now chain code is packaged as tar gzip, and so you should be able to write a tool yourself to package your chain code for execution. And as we mentioned earlier, some of the other provided libraries and APIs can also, the JavaScript and Go can package a chain code for delivering it and installing it and managing it as part of the lifecycle of a program instead of as going in and doing pure CLI. Okay, so now that we have a chain code package, what do we have to do? We have to install it, and then we have to instantiate it. So first, let's see what's installed, and we know that nothing's installed because we didn't install it, and it's not installed on either of them, so that's good. And then we're going to do another peer command. And we're going to peer lifecycle chain code install, and that's pretty simple. And if we take a quick look back over here, we can see that as part of the installation command, it's taking the package and it's going through the package and looking at it and preparing it for running. And so that is a step that happens and takes a bit to occur. But at this point, you can see that we've got some logs that say, okay, it's installed remotely because this is running on the peer, which we're not on the peer here, we're on a CLI that's sort of adjacent to the peer. So we do that in both peers, and again, we'll get another one that is running. And it's important to note that this runs and then it goes away. So it is just a little step that occurs to take the package chain code and prepare it for running. And this has been split out into the external builder, which will allow you to run and create chain codes in any language that you can manage yourself to manage the entire lifecycle of. But the Docker, the Golang and the Node and the Java chain codes are the ones that have built-in support. But you could do Go with the external builder or Node with the external builder as long as you have your set of scripts that correctly manage the chain code. So now what we look at, we can again query for what's installed, and we can see that we have FabCar1 chain code installed here, and we have FabCar1 chain code installed over here, and we can see that they do actually have the same chain code ID. This just happens to be the case because this is a very contrived example, and we have exactly the same code that's being mounted and packaged. If I were to write the same chain code in another language, we would get a different package ID because it's a bunch of hashes basically, and it cascades and becomes a different package ID other than the FabCar1 part. All right, so now we have the chain code installed on both of the peers, and we need to commit it. We need to approve it we need to approve it by each of the, we need to put it on the blockchain basically and approve it so that we know what has been put onto the blockchain by each org and what each org has approved. And so let's first take a look at the check commit readiness. And so commit again is the part that we have to do, is the stage, sort of the staging before we can ask the network to instantiate it. So we know that we have both peers have the chain code installed, but they don't have it approved for running, and they don't have it running. It's just sort of prepared and ready. As part of that, I want to go back over to, I want to go back over to the log just so you can see that we haven't done anything that has affected the blockchain yet. We're still sort of at, the channels are configured and ready to go. And that's just important to understand, when does it become involved, the chain code lifecycle become involved on the chain itself. And so now is the part where it does. So we go back here, we can see check commit readiness. That is it ready to be committed? And you can see that we have approval for each org. and we have a consistent, oops, we have a consistent view of that on both peers, because again, they're looking at the same backing blockchain and distributed and all that. Okay, so now we will approve each, we will approve the package for each org, and I'll go through that step by step. And so I'm on org 1, so this is org 1 approving chain code with chain code ID or package ID. And this is going to create a new block as it sort of creates a transaction that says, yes, I validate that this package is ready to go. So you can see we are going to the channel and we get a transaction valid. And so now if we look here, you can see we have a block that contains our validated transaction. And if we check our commit readiness again, we can see that org 1 has validated it. And this is the perspective of org 2. And from org 1's perspective, yep, it's validated it. So we're in sync still. So I'm going to take that guy and we're going to approve the chain code for running on org 2. And again, we've got a nice new block with the transaction in it. And now if we look at what's ready to be committed, we can see that yes, org 1 and org 2 are both have the same view of the world and both have approved it. And they both have to do this because so I think the default policy is majority approval, and a majority of 2 is 2. So, okay, so now that it has been approved, we can check and see whether or not it is ready to be run by checking whether or not it's committed. So we can see, okay, there's no chain code definitions on the channel. So we have to commit this, and it doesn't matter which particular peer, which particular org does the commit. I'm going to do it on org 1 here just because I can. And we got this giant command that's basically pure lifecycle chain code commit, and then a bunch of information on how to connect to all of the various participants in this network. And so we have to go to each peer, and so we've got a transaction on both peer 0 of org 1, peer 0 of org 2, and yet again we have a new block 5 that says, hey, this is the transaction that adds the commit, adds the chain code as committed and ready to be executed. And because of this, we will now have more containers running, and these containers are running the chain code of the actual packaged, installed, prepared, and now it's running. And so these are where the transactions will be run if we submit transactions to the network. And so once again, we can say, okay, well, what's committed on this channel? And we see org 1 knows that, yep, we have a valid FabCar version 1 on the My channel. And as again, for consistency, we can see that org 2 also has the same chain code definition. All right, so now we can actually start to interact with the chain code. And the first thing we need to do for our sort of example here is put some data in it. Because
Hi, Morgan, this is Jordan. How much more do you have in the demo? Because we're running a little bit over with the demo.
Okay, I can finish up in a bit, couple minutes.
Okay, thank you.
I just want to show an actual transaction executing here.
Sure.
So we can see that there's no data first in the, first thing we can see that there's no data in the chain as it exists. And so the first thing we want to run is that init that we showed in the chain code. And then we can run the init ledger function, which will initialize the ledger as it says. And again, we get a new block, so we're at block 6. And if we query, we have all the cars to interact with. I can stop here if we're in a rush. The next part would be showing how to use the API to interact with the chain code.
One quick question. So I understand you are showing this through the commands. Like, I thought there is one utility called Cello. So can you use Cello to do all these things?
I'm not familiar with that.
Okay.
Cello is more meant to deploy your networks. It's not necessarily used to actually run the transactions or things like that.
So by deploying the network, what do you mean? Like starting peers and all those?
Yeah, but Cello would have, so this example is kind of done all Docker based, but Cello would be able to run things like in terms of getting them set up on VMs and kind of creating that infrastructure that you want. So it's more of a deployment tool rather than a tool to interact with the network.
Okay, thank you.
Yeah.
I would just like to leave us with some resources if you want to learn more. There's obviously a higher level set of APIs that's available for interacting with the chain codes provided in the languages of Node. So you can use JavaScript, TypeScript, Go, and Java. But of course, the API is a bunch of open standard sort of protobufs and whatnot. And so if you can implement something that reads and writes those over a TLS connection, then you can interact with your chain code. But if you want to learn more and you want to talk to people, I would suggest going to the Rocket Chat, which is sort of a Slack, open source version of Slack, where you can chat with people and get information. And then the wiki also has all of these sort of meeting and calendar on it to get connected. So
great. Well, thank you very much, both Shweta and Morgan. I think that was a great overview of Hyperledger Fabric, and makes it very clear what all the different components are. And I think most importantly is this idea that you have different organizations. So very much like what you just went through, Morgan, a lot of people are not accustomed to having these different organizations that have to communicate with each other and make sure that they can, validate, carry out consensus, validate smart contracts. And that is a new and potentially difficult step for a lot of people. So it's great that you were able to go through that and help people to understand, how important that is. And that without that, you don't have a blockchain. You don't have a DLT.
To understand the participants are involved and they're known and they have identities and that they manage the blockchain and how it participates through itself. So
exactly. And with that, so thank you both. That was great. That word of identity, I'd like to hand it over to Riley and Tomislav, who will tell us a lot more about identity on the blockchain.
All right. Thanks, Jordan. I'm going to start. by sharing the screen. Let me know if you guys can see it.
Sure.
All right, excellent. So I hope everybody's has still some attention ability left for presentations with really good content. Can be a lot, but we'll try to keep this presentation a little dynamic and fun. We will talk about digital identity and how blockchain allows for a new generation of identity to emerge. So far, when we thought of identity in a classical sense, we usually think about, username and password authenticated against a certain service, and that's my identity. But the problem with that is each service is a centralized system, and then we rely on that service to authenticate against different services. There's no one way to say, I have my identity and I can present it multiple times to different organizations, to different services without having to register with, Facebook, my bank account, et cetera, and so forth. So this is kind of a short definition of what a self-sovereign identity is. We're going to talk about that term a little bit. This is just a short overview of what we're going to talk about, digital identity renaissance. We're going to go over some of the projects that you've already seen in previous slides, specifically in the areas in URSA, and how they compose this larger identity platform, and then some use cases, examples, and a little bit about Trinsic. We've already done introductions, so I'm going to skip over this slide. This is an interesting story, a true story that happened to me that we like to show as a reason why self-sovereign or digital identity is really needed, especially in the age of, it's 2020 and there's all these cool technologies. However, we still rely on physical documents to assert something about ourselves. So a few years ago, I was renting an apartment in Manhattan, and my agent requested all this documents for me to show that I'm eligible to to rent an apartment, or, to be able to pay the lease. All kinds of documents, bank statements, investment records. For some reason, they also wanted my marriage certificate, which is really weird. But what happened next was, after I supplied all of this data, my identity was compromised a week later. So there was an attempt at my bank to, with a bad check, to withdraw money from my account. And the reason why these people were able to do that was because they had every information about me, my bank account, my social security, my name, full address. They were able to replicate my identity, and the bank did not have any means to check that. Thankfully, they didn't. It wasn't successful, but still, the system. It just shows how the system is needs an evolution. We need to think about employing digital identity a little bit more, in a sense of how it can help us with this kind of problems, specifically replacing physical documents with digital IDs. And blockchain can help with this. This is an interesting cartoon from New Yorker that says, on the internet, nobody knows you're a dog. This is one of the root problems of digital identity, that there's no way for you to show who you are, or say some things about yourself without, scanning physical documents or things like that.
Thomas Love, it could be that you're the person that was trying to compromise your identity with your bank was a dog. I mean, you never know.
May very well be, yeah, exactly. Could have been. So, Riley, do you want me to go through this, or do you want to take over, or?
Yeah, I can sort of speak to these slides. Basically, Thomas Love, you did a good job of illustrating the problem. The reality is that identity is such a human concept. It's something that, like, people's gender identity, or their political or socioeconomic identities, or their family identity. These are things that are so personal and human that it's really hard to reduce them to an ID number or a hash or some username, password, or something as simplistic as that. And so the solution is to make digital identity as rich and nuanced and legitimate as a real world identity. And the way we do that is through a technology called verifiable credentials, which is a new W3C standard. And it's the way that Hyperledger, Indy, Aries, and Ursa help us to achieve self-sovereign identity. So you can see in this diagram on the screen on the right-hand side, we have, basically cards which contain data inside of a wallet on a mobile device. So Tomislav, if you want to kind of go to the next slide, this is if I want to talk about if Tomislav were to use this verifiable credentials technology in his rental application, what would that have looked like, right? How would the world be different if he had done that? And the first step is that the landlord, well, really step number 0 is that Tomislav has to get those credentials in his digital wallet, right? And then step number 1 is when the landlord requests some information from him. You can go to the next slide. When he gets that request, the wallet identifies all the relevant information inside of his credentials, which are needed to satisfy the request from the landlord. And then next slide, you'll see that step 3 is that those pieces of data are sent to the landlord. And the landlord is able to cryptographically verify that each one of those items is legitimate. And we'll talk about how that happens in the next slide or in the coming slides. So really, yeah, you can go to the next slide. This is what we call the digital identity renaissance, because it's going from our place in digital identity as subservient to some organization where they are an IDP. They have to be our identity provider. They provide us an account or something, and then we evolved to where big tech companies often proxy us in federated identity systems with login with Facebook or Google, that type of thing. And of course, there's a lot of problems with that with regard to trust, surveillance, privacy, and compliance. And so that's not an ideal solution. So this has evolved into what is self-sovereign identity, where instead of having a company as an IDP or a third-party big tech company as an IDP, the premise is that you are a human being. You have an identity. You are your own identity provider. So you have a self-sovereign identity, and that's where that term comes from. The idea is that you have some boundaries or some a little jurisdiction, which is yours and yours alone. And while you have to interact with others, and it's really important that you have relationships with government and financial institutions and others, right? You're not totally self-asserted, but you are self-sovereign in that you can own and control your own identity and your own personally identifiable information. And there's a lot of standards that go into how that works. And so this we call the SSI trust model, and this illustrates how this comes into being. So the way it works is really similar to how things work in the real world. You have an issuer who issues a credential to a holder, which is a person. Usually they hold it on a mobile device. And then when they want to use that credential, they can share it with what we call a verifier. And as long as the verifier, so when the verifier receives it, right, they'll receive the data, and it will be signed using the issuer's private key, and the issuer has a public key that the verifier has to check against. And as long as the verifier trusts the issuer and knows whose public key that is, and they trust that public key, and there's some assurance around that, then this model works really well. And if you can click the next button, you'll see that there's some titles that come up, right? So like an example of this would be a bank issues a credit card to a card holder, and that card holder uses it with a merchant. And as long as the merchant trusts the bank, the credit card transaction is cleared and everything, is all hunky-dory. So if we go to the next slide, though, you'll see this gets a little bit more complex when there are, sorry, back one. You'll see it gets a little bit more complex when there's a lot of banks, right? How does the merchant keep track of 12,000 different banks in the world? So if you go to the next slide, you'll see how that happens. There's somebody like MasterCard comes in and says, to the merchants, hey, you just have to trust MasterCard. MasterCard will provide a platform to all the banks and will help navigate all the regulatory and governance problems or implications of this. And the trust ecosystem can scale to billions of people this way. And what self-sovereign identity allows us to do in verifiable credentials, together with Hyperledger Aries, Indy, and Ursa, is that it allows us to take this model, which is really common in the banking world with credit cards, and to generalize it for any data that you can imagine. And so if you go to the next slide, we'll show where Indy, Aries, and Ursa sort of fit into this model. So Hyperledger Indy is at the bottom. It's the blockchain. It's nice because it's production ready. It's being used in production by us and by other people as well. And that is an instantiation of Hyperledger Indy is called Sovereign, the Sovereign Network, which you may have heard of before, but basically it's just a production instantiation of Indy that's up and running with hundreds of organizations using it. And then above the blockchain, you need what's called an agent. And an agent stores and manages keys and wallets on behalf of people, right? Because I'm not going to remember my whole private key. I need some software to help me remember it. And so that's what agents do. Agents store credentials and they help manage them in that way. And then a layer above that is where the actual issuer software and verifier software lives. And it speaks the right protocols. There are, just like OpenID Connect is a protocol for authenticating people, using third-party identity providers. There are emerging protocols for credential issuance and verification that the issuer and verifier softwares need to speak in order to interoperate in these new ecosystems. And that is what Hyperledger Aries does. So Hyperledger Aries is really the protocols and libraries for enabling the interoperable credential exchange. URSA are the cryptographic libraries and cryptographic kind of roots of the zero knowledge proofs and other powerful capabilities within self-sovereign identity. And Hyperledger Indy is the blockchain underpinning it all, which enables it all to work. So if you go to the next slide, Tomislav, you may be better suited to speak to each one of these projects, but just want to dive a little bit deeper into each one before we get too far. And then I think we could probably pause for questions.
Yeah, of course. Well, are there any questions so far?
Yeah, I have one question.
Mm-hmm.
So in the previous presentation on the Hyperledger, or in the previous to that on the quorum. So let's say this is part of the Hyperledger. So would these identities work with Hyperledger Fabric, because that was using a different model using certificate authorities and other things, right?
Right. Not directly. There are efforts to integrate Hyperledger Indy with Fabric, but I'm not sure to what state that work is. But definitely, it is possible. Theoretically, it is not possible practically right now,
okay.
But it has been discussed. Yes.
Yeah,
Okay,
the direct integration isn't necessarily possible right now, but it is possible to do business workflows and smart contracts using Hyperledger Fabric, and separately to use verifiable credentials for other use cases in addition to that, and sort of use them in tandem for what they're each best at. I think Hyperledger Fabric, Hyperledger Indy and Aries and whatnot are purpose-built for identity, and they do their job very well. They're very specialist in identity. And so if you need basic identity things like just having an identifier on a ledger that can be trusted by a consortium, and other more basic identity things, and Morgan or whomever, feel free to jump in here if you have thoughts, but Fabric works well for some more basic things. And then I think Indy and Aries, when you want to be starting to talk about medical records that you want to issue to the end user, where the physical, like the actual storage of the data is on their mobile device rather than in a ledger or anything like that, then Indy and Aries work really well. So I think they solve different problems, and they can be used in tandem, but there's not a direct integration between them.
Okay.
Yeah.
So what you're suggesting is that on Hyperledger Fabric, so if the user is using this type of applications, then they would have an identity for Hyperledger Fabric, traditional one, and then they would have additional identities using Indy or something for, right? And
yeah.
they will sort of orchestrate. I mean, the application will have to orchestrate that.
Yep.
Yeah, that's
Okay.
correct. You would use both ledgers to make the integration, but obviously you would have to have reference points for, on Hyperledger Fabric, for example, you can have an identifier that says this is my identifier. You can resolve it on Hyperledger Indy. The point of integration was to rewrite the certificate authority so that it relies on decentralized on indie authentication rather than a standard trust root.
Sorry, I didn't get this last point.
The certificate, the CA from Hyperledger Fabric, is the point of integration, so that module can be swapped for a module that understands Hyperledger Indie. That was the plan, at least. Again, I think IBM is working on it or is still in the backlog.
Okay, thank you very much.
I'm a little curious about the unbanked world where we don't have any of the certifications, especially Asia and Africa. How can we use, or what else can we, like, I think Jordan might have just hit on something when he said you can use, Jordan, what was your suggestion right now to Ashutosh? You suggested you use something from Hyperledger Fabric with this to kind of create an identity for, or I'm not sure what you just suggested, but basically build on.
Yeah.
Sorry. So looking at.
Go ahead. That was me. It wasn't Jordan. This is Tomislav speaking.
All right. Sorry.
Right. No worries.
I'm trying to figure out what you do for the unbanked world where there are nothing, and the only basis that, so these guys are just coming online, and they bypass any paperwork. So we don't have landlines or phones, or we have mobile. That's the kind of world we're looking at, which is just bypassing all this and coming onto the world. So their identification will be from what, or the transactions they have online. What would be the kind of certificate? What could we add to your sovereign tool to actually make it even for the unbanked world? To kind of give a certification or a validation to the unbanked world.
Sure. We actually worked on a project that was serving identities for users who don't have smartphones or don't have internet, but only have access to mobile. The solution for that is to use cloud wallets and cloud agents in a sort of a custodian or guardianship role that acts on behalf of them, so that each individual has a wallet and has an access to the identity system, to their digital credentials, but those are not stored on their mobile phone in a smartphone app, but instead they're stored in the cloud. So
yeah, I think
that's one way to approach this.
The traditional smart cards would also can also be used, right? The identity could be stored on a smart card, and then smart card is, or smart chip, which the user possesses. So
yes, that's possible as well.
The other interesting thing about the project, that approach.
Yeah, definitely. The other interesting thing that I'll add to what Tomislav said is, for that project in particular, they were empowering smallholder farmers, and what they were doing was issuing credentials that were based on the transaction data that those farmers had accumulated over time, so that then they could use those their previous transaction data in order to prove that they were the farmer that interacted in that way, so that they can apply for credit and actually receive credit and become banked for the first time, because they can prove that they were able to have a steady income over the last however long. And the supply chain activity for that project was actually using Hyperledger Fabric, and the identity aspect was using Hyperledger Indie Aries. And so that's actually a really unique example of where Indie, Aries, Fabric, and Ursa all came together to do something really interesting.
Yeah, this I was going to say.
That sounds really interesting. Would you remember the name of the project? I'd love to study that one.
Yeah, the project is called Farmer Connect. So you can go to farmerconnect.com and read more about how they did that.
Yeah,
thanks ever so much.
The supply chain solution is based on Hyperledger Fabric, specifically on the IBM's Food Trust Network, and then the identity is based on Sovereign Network. All right, so Hyperledger Aries, we talked a little bit about that. Aries is a message exchange protocol, to put it very simply. It's a set of tools that provide means for the three roles that we saw, issuers, holders, and verifiers, to exchange credentials. And Aries prescribes a certain protocols that says, you know, your messages, when you exchange them, they need to be encrypted a certain way. But it does define a way how two entities can communicate over the internet or over an offline route. For example, the protocol is transport agnostic that you can potentially mail somebody a credential, and they can scan a QR code and use that credential, actually. Some reference implementations here. AMAX is Aries Mobile Agent for Xamarin. This is a reference implementation that we did that showcases how you can use mobile application to store digital credentials. And then Akapai and AF.NET are frameworks for working with cloud agents. Again, agents in a very simple form are just services that facilitate the exchange of messages. Hyperledger Indy, this is the set of tools. The Indy node is the one part of Hyperledger Indy, and the Indy SDK is a library that allows access to Indy, but also access to low-level crypto that are used in the Hyperledger Indy credential exchange. Hyperledger Ursa is, it started off as an extension to Hyperledger Indy, or it was born out of that. The actual low-level crypto that Indy uses is hosted and done by Hyperledger Ursa. The current production version of the crypto suite is called Anon Creds, using CL signatures. I'm not going to dive into details, but these types of signatures allow a complex set of interactions and verifications to be done that also supports revoking credentials and tracking revocation registries with the help of Hyperledger Indy. And then the next iteration of that in AnonCreds 2.0 is something called BBS signatures, which is an improvement over CL signatures with faster crypto performance, and also has other interesting extension features. Riley, over to you.
Yeah. So just, I don't want to, just conscious of time, don't want to go too much into the minutia here, but there's really a lot of value in giving the end user physical control over their credentials, and because they become, in a lot of ways, the owner of those data artifacts, and also the point of integration potentially between multiple service providers. So you can imagine a scenario where there are multiple service providers who don't necessarily want to use the same blockchain or necessarily play super nice with each other. But in a world where the end user holds these as credentials, those organizations don't necessarily have to play with each other very nicely. They just need to support this standard, which again is, it's a W3C standard. So it's not just a sort of de facto standard because more people use it. It's actually a really kind of legitimized standard. And then they can speak this as well. And then you get all the benefits of the blockchain in terms of, finality and in terms of decentralization. But you also get these other things. So these are some of the things on that list, right? Improved conversion means that, if you're a bank and you want to onboard a new customer and they already have the driver's license in their digital wallet, you don't need to do any big KYC checking on them. You can just directly onboard them, given of course, I shouldn't be too oversimplified, right? There's still KYC checks that are done, but the process can be much smoother, and the conversion from one step to the other in the process can be improved greatly. Another thing I'll point out is just verifications, right? If you need to verify that somebody is actually a doctor, with self-sovereign identity, that doctor can directly prove to you that they are a doctor instantaneously, and you can verify it cryptographically. So anytime some verification is costly or time intensive or anything like that, SSI adds value there as well. And then there's sort of risk and compliance things that are greatly improved, right? If you're a business, you may not want to hold toxic data like social security numbers or birth dates or things like that. And by using SSI, you can avoid having to hold that information and instead allow the end user to hold it. So if you want to go to the next slide, Tomislav, there's a couple of use cases. Farmer Connect is the first one. We already talked about Farmer Connect a little bit. They're empowering farmers with their data and in turn, enabling the farmers to have more access to credit, which then gives the farmers the ability to expand their farms, which improves the bottom line of the supply chain companies that they serve as well. And so it really is a virtuous cycle, and that's a really interesting use case there. MedCreds is a company in the United States that is doing COVID-19 test result credentials. So if you get a COVID test, instead of having your doctor give you a call on the phone or send you a letter in the mail or give you access to some cloud-based web portal that has complex authentication schemes. In fact, when I got my COVID test, I had to use my social security number to authenticate, which is a terrible, terrible, terrible thing. MedCreds is enabling patients to access their COVID-19 test result credentials in the form of a verifiable credential issuance just in an instant, right as soon as the credential or the test is validated. And then CU Ledger has a product called MemberPass, which enables credit union members to authenticate, have a single authentication channel and scheme to use across all channels. And it greatly reduces call center fraud because when somebody calls into the call center, they have to present their MemberPass verifiable credential, and it's a much stronger authentication. And then there's plenty more that we could talk about, but again, for the sake of time, I'd like to get into the next aspect. So we won't talk too much about Trinsic, although it's my favorite topic to talk about, of course. But Trinsic really is just a full stack verifiable credential and digital wallet platform where we have all the tools you need to use verifiable credentials, both issuance, verification, revocation, management, etc. And then digital wallets, right? Whether that's a mobile wallet, a web wallet, or whatever you need, we probably have the tools. So we have 3 different APIs and SDKs in 5 different languages, and several hundred developers that use the platform each month to bring their verifiable credentials use cases into production. So that's Trinsic. I figure with oh yeah, here's a little bit of an architecture of how that looks, right? So I mentioned we have 3 APIs. You can see at the bottom of this product stack, it says the Trinsic Cloud Platform, right? So we have a cloud-based strategy. There's really 2 ways to have a business model in open source that I'm aware of, and it's basically a cloud strategy and a consulting strategy. And there's also other ones, right? But the 2 main ones are those 2, and we are the cloud strategy. And so we have a cloud platform. We have what we call the provider API on top of that, which enables you to create what we call organizations. Those are issuers or verifiers of credentials. And then from organizations, you can create individual cloud wallets using the wallet API. And you can also create credentials, verifications, and connections with end users through the credentials API. And then sitting on top of the credentials API functions is a web interface called the Trinsic Studio that lets you get started just really quickly. So that's the Trinsic platform. Now, if we go to the next slide, you'll see sort of a tutorial. I think the best way to learn is by doing. And although we might not have enough time here in the session, I wish we did. We have a small enough group that it would be nice to just everybody go and issue some verifiable credentials to a digital wallet and see how it actually works. Anyway, this is the, at docs.trinsic.id, you'll find all of the documentation for you getting started with Trinsic. And we have a nice tutorial there that kind of walks you through the different use cases. And one thing I didn't mention is, but I hope was implicit, although I didn't make it explicit, is that Trinsic is built entirely on the Aries and Indy and Ursa platforms, right? So we contributed one of the Aries frameworks in our whole product stack. All of those different APIs and everything you see there is really based on Hyperledger Aries. And so the best way, in my opinion, to get familiar with Aries is to go to the Trinsic docs.trinsic.id. You can, authenticate. You can get into the Trinsic Studio, really quickly and get started issuing credentials in 5 minutes. And it's very intuitive to get started. And then the APIs are quite powerful when you want to go to the next level. And it's a really good way to get started with Indian Aries. And then once you sort of get it conceptually, you've built your proofs of concept and everything like that, you can sort of make a decision with regard to where you want to go for your next steps. And we had some examples in here of places, Aries code bases that you could look at for your next step if you want to use Aries. And of course, you could use Trinsic's platform or any number of other companies that provide a similar offering. So that is kind of our presentation. I guess what other questions are there? We already got a few good questions. Curious if folks have any more.
Well, that was a great presentation. Thank you for taking us through, Riley and Tomislav. It's kind of getting late for a lot of people. I mean, you guys are on the East Coast, so you understand. And, we have about 24 people that were signed up, but I think 3/4 of them were in India, and they're waiting for the I've been notified that they're just going to wait for the video of the session. So we had some people that were actually able to be on and see this live, but many are going to be viewing the video and will follow up with us. So we do have our contact information in the different presentations, and there was a lot to take in. From all the stuff at the beginning about blockchain and DLTs and thinking about the philosophy and use cases and great examples to Hyperledger Fabric and how it's used and basically its components and structure, to Hyperledger, Indy, Aries, and Ursa, and the work that you're doing at Trinsic with your platform to make it all that easier to access, easier to deploy. So, are there any other questions from anyone at this point on anything that we've covered? It's been quite a whirlwind session. Okay, wow, 5:30 a.m. Yeah, there's a lot of people that are in India, and thank you for being with us through your night. And thank you to all the speakers, and thank you to the attendees. And we will make the information or the presentation available. It is being recorded, and anybody that's signed up will get that. So feel free to follow up with any of the speakers, and we look forward to seeing you tomorrow at TiEcon and being in touch in the days ahead. So,
Jordan, thank you very much. They were great sessions. Thanks everyone who presented. It really was a wellspring of knowledge for us. Good night.
Wonderful. Good night.
Thank you.
Get
Thank
some
you
sleep.
very much.
All right. Thank you all. And
Thanks all.
thank you for being part of this. Bye.